Hey, can you hear me? Just checking the audio. Hey guys, can you hear me okay? Hello? Hello?
Right.
Hey, checking if you can hear me. Hey, can you hear me? Hey guys, can you hear me? Just checking the audio. Hello? Hello?
Hi, Niraj. This is Salam. Yes, I can hear you.
Okay, good to know. Good to know.
Okay.
And you're able to see my screen, are you?
Yes, I can see.
Okay. Okay, I'll just turn around. Hold on. There we go. So we should be able to see me also. There we go. Hi. You see me?
Yeah, hi.
Okay, good. Good, good, good. So how are you doing? How are you all doing? Let's see. Are all of us here already? I see four of you, not all of you yet. If my audio starts to, oh, there is Anand coming up. We have almost everybody. So I'm going to just set some mapping for the pen a little bit. And it should be okay now. Okay, so we have most of us, except I'm still waiting for, I think, a couple of you. Oh, she just came in, and Sri will also join in momentarily. So we should start now. We should start. So just quickly checking that part. I am going to quit this app. And let us continue. Let us continue the discussion we were having the other day, which was about a couple of things we were doing with this Cloud Genius Bootcamp. And let's get there. So by the way, the site performs better than what it was before. That is very nice to hear. Is that correct across the board or only a few people? Is it across the board? You're finding it better?
Yes, that's correct.
Okay. Okay. So you know what I really did? That the trick was to move away from the current provider to a new provider, which has recently came up, by the way. It's a very new company. The name of this company that I just started using is this. It's Vultr. I don't know how to pronounce it, but I just like to call it Vultr. That's the name. It's a new DigitalOcean, very much like DigitalOcean, and new SSD-based high performance, new machines, and multiple locations. That's what they just started. And the pricing is kind of sort of like DigitalOcean. If you see that, the similar pricing.
How long they are in the market? They just started?
They just started, so I just took that. I take risks. So sometimes.
That's a price is good for now.
Yeah, price is good, and I think the machine performance is also pretty nice, which is what I like. And then I thought, why not just give them a shot? So I give that a try.
Yeah.
Turning out to be really, really good.
It
I
is fast.
did some testing also. The unfortunate part is that they are so new that they don't have what I would like to have, which is plugins for Knife and other tool sets. They're still building it, so it's not there yet. So we cannot run it with our chef exercises quite yet. If you try to search for Knife Vultr, you will find that there is a GitHub repository, but if you go inside the repository, it doesn't contain anything. It's just a license file and a README file. That's it. It doesn't actually contain anything. And the issue that they have is this plugin function. It's not even a plugin. I mean, there is nothing in it. So somebody's asking that question. It's an empty repository. Somebody's trying to build it at last year, apparently. They started it, and then, yeah, it did not build quite yet. But if you want to develop your own software or your own plugin, you can totally do that, because there is an API that these guys provide, Vultr API. Let's see, what APIs do they provide? It's fairly simple to actually use. The whole API reference is available, and what I can potentially one can potentially do is develop their own plugins to work with whatever you want. So that is what I essentially did. Some of you are interested in understanding how I actually move this entire machine from one cloud to the other. I literally took that entire Docker container, which we have. The Docker actually is not one container. There are 4 containers. There are 4 Docker containers that run that site. This site, this one. And so this site is run under 4 containers. That's what we currently have. What we in the 4 containers, what we use are one to store data. That's it, nothing else. It's just a disk. And then then we have a database container. We have a application container, which basically runs Apache and PHP and WordPress. And then we have a front end here, which is like a proxy. Hey, we have some noise in the background. If you can mute, that would be awesome. So please mute yourself if you are the one that is generating noise. Somebody's talking in the background. So the proxy layer, these 4 containers that we currently have, they all together sit in a Docker cloud, a Docker cluster. And that cluster was running on that machine, which was in Azure. It was 2 cores, 14 GB RAM. And basically what I did is moved that entire cluster away from that location over to this new Vultr. And that movement happened. This one actually is a smaller machine. It's 4 GB RAM, but it works better. If you look at the performance of that machine, if you'd like to see that, let's see if you go to terminal and make it big and connect to the machine. The machine is breathing normally. Okay, I have a host key verification failure, which is basically my stale record. For known hosts is basically bad. That's what I just did. And now I can connect to that cloud. Okay. My key is not in use, so I need to get that key added. And now I should be able to connect just fine. And here, if you see the performance of the box, it's pretty low, like, very low in terms of CPU consumption, 1% right now. The memory consumption is about, 1000 MB out of 4 GB. So it's nice. The overall CPU consumption is very low, and you have all these things running in there, basically Docker Cloud and the whole suite. And we will do this by the way, the exercise that I want to be able to do is with you guys on using Docker. You will be able to do such things yourself once we get to that point. And this is what you see running in that box, multiple containers primarily. And if you see the images that I am using, these images that I'm using currently in that box, and the box itself represents these 4 layers. So independent containers doing independent things. And That's how I currently have. In scalability here is very simple to actually administer. You can just add more of Apache if you like, and it scales out like this. If there is more traffic that people hit, then it can just scale out. But the underlying machine has to be capable of performing, and that was not good, not good. And not just the machine capabilities of cores and memory, but also the network was slow. I was able to verify that also. The network to Azure and outside on the internet is very slow. The network here is pretty damn fast. If you go look at the, the ping characteristics from my location to that box, the ping numbers are really, really slow, really small. Let's see, 14, 13 milliseconds. Really impressive numbers that we have there coming from. So basically this machine is like in Seattle. So ping for me is very low. Ping for you in New York should be like maybe about 50, 60 milliseconds, not more than that. And California should be even lower than 50. So that's what I'm expecting. That's why you're seeing good performance. The network is good and all that good stuff. So cool. Next thing, what I did the other day, if you remember, is that we used Chef to deploy a complete stack on one box. So one box had the whole thing, which included a complete representation of WordPress running on that box itself, which basically said, you have to have all these things that are required to make it work. So we did this exercise all the way up to this point, where we were able to deploy end-to-end and run and watch WordPress live when we ran this one long command. Basically, we are saying the name of the machine, image, location, size, identity, bootstrap with Chef, provide the key, set in production environment, and excuse me, add all the roles like base, DB, master, web server. All of these roles added on essentially led us to get a box that gives us ready WordPress in one shot. And that's what we did the other day. Now, we also discussed about, this is, by the way, the other command is for another cloud. So you can basically run similar commands in other clouds. And the code for reference that I have provided is in this repository. So if you can go to that location, that is where you can actually download and compare notes in form of what I have used in my example. I have given a link out to this repository, which is where I have given all the code that I used to use in the exercise that I was running with. When I finished the whole thing, that is what I provided here. So you have a copy of my Chef Knife RB, and this Knife RB contains my access key and my secret access key and my DigitalOcean token. But don't worry, I have disabled these tokens, and there is no reason for anybody to worry about that, or reason for me to worry about somebody hacking my account, because these keys are destroyed. They're not really active anymore.
You deleted it, okay.
Yeah, so that's the key thing you need to remember when you're dealing with these items like security keys, access keys, secret keys, and tokens, that you never, ever give out like this to GitHub. You don't, but I have given it so that you can see. But these are deactivated, so you basically nobody can misuse it. That is the one thing you want to remember when you're giving keys, and I'm repeating this many times. Probably I should not, but the repository is here for comparison, for reference. So you can compare what you are doing on your own machine with what I have done on my machine. So you can basically compare notes. Now, having done this part, the other discussion we had was to do that next logical separation, the separation of concerns, which I mentioned a while ago in the last session, which is, we are running all of these things in one box, but the primary concerns that we have is to be able to serve the application and have a database to serve the app itself. So the users will get service from the application, and the database will serve data to the app. And this is the user. So that's the primary way to disaggregate and separate concerns. So the separation of concerns is what I briefly discussed, and I also gave you a cheat sheet in GitHub, which I think at least one of you, Tick, completed that on his own, and he now has, basically modified the repository that we have with roles that we have identified. For example, what Tick did, and I think Tick is online. Let's confirm that. Yeah, Tick is online. So what Tick did was to be able to modify these repositories in the repository, modify the DB master role, and in here added PHP, added module MySQL for PHP, and the DB user recipe that we created ourselves, that entire cookbook, this reference. And these three were added on to the database master, DB master role, that modification. Because what we are really trying to accomplish is the idea of separation of concerns. So this DB master role will get applied to this box. It will basically become a different computational unit. And this becomes another computational unit. You can think of it, this one as maybe droplet number 1, or droplet, and this one is droplet number 2. So two different droplets where you apply the DB role to this box and the app or web server role to this box, and then you connect them together. And that's essentially what that next exercise was, which I gave out in a Git gist, which I think you can use the gist, but what I now have is actually created a separate unit dedicated for that. It is the module number 9. That's what you will see here. And it is about addressing separation of concerns, creating a separate app server and a database server. And that's what we are essentially doing, is putting the database related elements, including the language needed to operate on a database, onto the database role here. And in addition to that, what we have done is the web server file, we removed the database master, the database references here. So DB user default, we removed that reference. It was there. Please mute. If you can please mute, that would be awesome. There's some noise coming up. I can tell who's causing that noise. You don't want me to mute you. I would rather you mute yourself. Thank you. So the idea essentially was to remove the database reference from the web server role here and add the database references here in the database master role. That way we are basically separating the responsibility, the concerns about which machine should do what. So that function goes to this box, and this function goes to this box. So that's how we are separating concerns. And one last thing that needs to be done is to make sure that this connection establishes between the two boxes. The two boxes can talk to each other. For example, if you're doing it in Amazon Cloud and you have the DB box here and the app server, web server box here, then you need to make sure that port number 80, port number 443 is open for public access. Port number 22 is open for you. Similarly, you should make sure that this DB box that you will have, it should have port number 3306 open for this box to access that box. And that connectivity is important for you to be able to enable. If you don't enable those connectivity, it will not actually work. And that is going to be the next step. What we have done is, of course, we upload the roles to the Chef server and all that, but then we modify some access rules there. The access rule essentially.
I'm so sorry. Nilesh, this is Salam. So the connectivity has to set up prior to execute those syntax, correct?
You can open the connectivity later also. You can, bootstrap the machine, no problem, and use port number 22 to get there. For you to get there, that port number 22 is required. However, before this box talks to that box, you need to have this port open for this machine to talk to this machine. You can, of course, come in and set up the whole thing through knife command. The knife command, which is what we will run. There are two knife commands, basically, one for this box, one for that box. So 2 machines get started. This box, the app server machine, and the database machine. This machine has a separate knife command.
I started this morning, but it's showing error to me. I don't know. I gotta check it out. So how Tick did it.
Okay, so you should refer to this particular exercise here. I have a reference for you there. In that, I'll make sure that I grab it and paste it over in Snapchat. So make sure you.
I need to know the step by step when he.
Here it is. So here it is. The step by step is in Slack chat.
Okay.
Yeah. So the idea essentially is to establish that connection that we want to be able to establish. What we are essentially doing is, okay, with that back here, is we are running the app server related role, the web server related role that we have, the roles. These roles get applied to this box, and the database role applies to that box. So then we have an app server running here and a database server running here. We still need to open up port number 3306 and then allow this box to connect to that box and have a user account that has permissions to connect to this database. That permission has to be enabled. And that permission is what is shown in this example here. You're basically modifying the dbuser cookbook, install dbuser sh file to include an account for remote access to the MySQL database. That user account we are creating, like here, like this. We already create a user account, by the way, and that is this step. But we will modify certain things, like instead of this % and %, we used to have localhost before. But now we put percentage in there. Percentage is basically a wildcard character in MySQL syntax. So it allows you username at any machine to be allowed to connect to this machine. So this username doesn't have to be on that target machine, but on any machine. It can come from any machine and it will still be allowed. So this is a permission that we are opening up for the username to come from a different box and connect. So this user sits on a different box, and he or she, actually there's no he or she, it's the app user. This application will connect like this user and through this port onto this MySQL box. And that permission is what we are granting through
percentage.
Yes, through this modification. So the modify dbuser cookbook, this modification is what is basically going on to make sure that that these changes we have to basically do in the install dbuser command step that modifies permissions and allows this user on the machine A to connect to the database on machine for database. And that permission change has to be incorporated. That becomes a modification to the cookbook, the dbuser cookbook. So we take that cookbook and push it out to the chef server. So at that time, we have the cookbook that shows the latest changes in terms of permissions as well. And now at this time, we create 2 different commands. One of them is this command, which is the creation of application server. And you will note in the run list portion, the web server reference for the run list. And the database reference is missing. We removed it because that database reference here we used to have before in a previous all-in-one command. We put that database reference in here, dbmaster. So slightly different in terms of how you create the machines. The purpose in life, the DNA is different. This box will grow up to become a web server, and this box will grow up to become a dbmaster. you have two boxes going up and running. Once you have them up and running, then you need to basically start WordPress. And when you're starting WordPress, you should see what it does. And there is an example, I think, that Tick has provided me, and I'll just open it up. So let's see if I can find out what Tick emailed. He has a screenshot of what he did. I'm just looking for it. So here. So what Tick did was that he's opening up this machine, IP address at the top, 22600. That's the web server itself. But the database access reference in the database host, at the body of the page, you will see here, it is 102.71, which is the database host, which is a different host, not local host, not this number, 22600, but instead he's referring to the other box, the database host. And that change you have to do. And once it is done, it's just regular WordPress and a little bit faster. And then you can add posts and everything else. And the concerns are separated, and you can see that the site is up and running, and it is connecting. As far as database is concerned, it connects to the other box like this on port number 3306. If you run it on DigitalOcean, you don't have to worry about these things because it's all open. It's like jungle. There is no port level security. There are no concept of security group. So when you're trying it out first time, it's a great idea to just try it with DigitalOcean. And that is why at the very top, I actually mentioned somewhere that, try it with DigitalOcean, because, network is open. It's like a jungle, everything is open. There are no doors and windows and no security groups. And so anything can connect to anything else. Makes it easy to run first time. However, in real life, don't leave it like that. Keep it closed, put a firewall. If you don't have a concept like a VPC, or don't have a concept like security groups or other methods of network security, you should provide your own firewall, which is built into Linux, by the way. It is called IP tables. And setting up IP tables can be incredibly hard. However, there are some packages that are making it simple. And I will walk you through, if you are interested in that direction, of how do you manage a naked box, as I call it. This is basically naked. The whole thing is open. There are no protection on the network front on a box in DigitalOcean. Nothing is secure. Everything is open. That's why it is easier to run exercises on that machine. However, you don't go like that in the open like that. So you have to actually have protection. You have to have IP tables on Ubuntu can be managed very easily through. Yeah, here is a basic firewall implementation example. So you can maybe set up this instruction set. And so the idea is to be able to use. There is even simpler. I'll identify that right up somewhere. It is even simpler method of managing your firewalls using a ready-made package that will do exactly what you want, open specific ports and close everything else. And that is what I will point out later. But let's, for now, stay focused on what our exercises are, which is what I want to be able to do. And on some of you, like you wanted Saturday, which is tomorrow, I would like to have that chef exercise, redo, repeat the whole thing from scratch. I will do that tomorrow in a separate session. I'm proposing 5 o'clock as a time for that. And we will take however long it takes. Should not take too long, but maybe 1 or 2 hours. That's what I expect. On tomorrow 9th, we will do another session, extra session, just repeating this the most complex exercise I think we have, which is module number 8. And we'll also do module number 9, which is a follow-up, basically separation of concerns. And just to add some flavor, tomorrow, I will actually use Windows Azure. So we will use Azure tomorrow, just to give you a flavor of how it is different, how it is similar to to another cloud. So we have been using, these two clouds mostly, Amazon Cloud and DigitalOcean Cloud. But tomorrow, I will use the same exercises, everything same except instead of Knife DigitalOcean or Knife EC2, we will use Knife Azure. The different plugin, and it's also a gem available here. We just add that gem to our gem file, and off we go. Basically, as simple as that. There are some slight differences. We'll point them out. And in fact, they are already written down here for you. Optionally, try these steps for Azure Cloud. So that is also written here for you on the same separation of concerns exercise, module number 9. This is a new entry I added yesterday. And so this Azure is what another choice. So basically, it is cloud agnostic. You can run it anywhere, any cloud you bring it on, as long as you have a Knife plugin. These instructions will work just like that. And so,
Nilesh, Anand here.
Hi.
A quick question. I mean, I joined a little late, so I heard you were saying that Microsoft Azure was performance kind of slow. I mean,
Yes.
is it the open secret, or because I never been, I'm just checking to see. I mean, how come the other clients are not complaining, right?
I know, it's a very good question. So the other clients do not complain because...
No, in the sense because we know you're sharing this with us, right? I mean, let's say if someone wants to go on cloud, they usually compare AWS or Google and everything, right? So how come I still see, Microsoft taking a lot of other clients, as they're, just checking to see.
So, I think it is a good idea to read what other people are saying. So performance can be a very subjective thing to discuss and talk about, and people just use the word, hey, it sucks. But that's not the way to measure performance, right? Performance should be actually measured across through comparative benchmarks. So here people are studying their studies, and actually let's find out. So here is a price reduction mentioned, right? So you have to compare performance in the context of multiple things. First thing first, whether your applications will run there. Second thing, how much it costs for you to run it something, the exact same infrastructure application set. How much does it cost between cloud A, cloud B? The third thing is what aspects of performance are important to the user, to the end user of the application that you have. And then you have to come up with benchmarks that actually compare according to what the users want. Now, in my case, it was very simple. I asked you, hey, do you think that the performance is bad? And 3 of you said, yes, it is very slow. And then I randomly chose, actually, I knew about Vultr. I chose Vultr and I migrated there. And now I ask, hey, what do you think about the performance? And 3 of you say, yeah, it is good. So I think that is a conclusive test for me that Azure sucks, because I don't care what I see as the performance, but my users are you, right? You are the user. So you basically decide. If you find it is better, then it is better. I mean, come on. I will just shut everybody down and say my users are telling me that the performance on this Vultr thing is better than what it used to be before, and that is my comparison. I mean, that is the best benchmark, which is the customer says. You, by the way, are my customers. Just remember that. So you are the customer. You telling me that Azure was slow, this one is better. I mean, that's the best benchmark I can get. Any amount of, all these things, you have, let's see. There are more benchmarks. So here is a cage match, and there are probably comparisons and numbers and all that provided to you. And let us see if there are some. So you can study these things basically, but I don't really care. What I care is about you. If you tell me performance sucks, I need to, and that's how I operate. So you can read more such articles like this, like I'm showing you, and there are actually very good ones that I have mathematically compared with running test cases on variety of clouds, and you should take that into account when you are doing something on your own, when you don't have a customer to tell you, hey, this is good, or no, that is bad. If you have a customer, use them. That's exactly what I did. I asked you, hey, is the performance bad? Because I also felt it, that the site was slow. So I asked you. You said, yes, it is bad. Then I change it. Then I ask you again, hey, how is it? You tell me it's good. Beautiful. That, in my mind, for my case, is the best metric. And that metric is customer, you. You are the best metric for me. Everything else, I don't care. Honestly, I do not care. Anything else I don't care about, just about you. Because you are the customer, and customer is the king and queen. That's in my books. So you dictate if the performance is good or not. Now, having said, there are mathematical ways of measuring, and we will touch upon that. And I would like you to study these things on your own. There are tons and tons of examples provided by many people who have done these mathematical studies about what is better, what is not. But my benchmark is very simple. Is my customer happy? Plain and simple. No complexity involved. You just go to another cloud and see. It is easy for me to go to a different cloud because I have put all of that in a container. And I can just literally migrate the container wherever I feel like, including taking it to my laptop and run it right here. I could do that. I totally do that. And I have, in demonstrations, I can run a complete website right on this laptop, and then take that same site, run it in some cloud somewhere, or whichever cloud. You pick your cloud. As long as it runs Linux, it will run it. Because as long as it runs Docker, it will run it, because it doesn't matter. To me, it doesn't matter, because I have abstracted away from all underlying things that are needed for a machine to run, because I don't really depend directly on the machine itself. I depend on Docker, which deals with the machine, and I live here in a container. Actually, multiple containers. So we will study containers, and you will actually enjoy it, because it gives you this. I think we did briefly touch upon in the first module we briefly touched upon Docker, but we'll do more exercises pretty soon. As soon as this chef thing finishes, I will start focus on, and as soon as our next program, which is the architecture class, starts, we will specifically focus on Docker and build out a variety of architectures, which is actually very easy to build something, because you can conceptually describe and use and leverage work done by other people in the community. For example, I'll give you some brief hints. There is this thing called Docker Hub, which I think you should sign up for. It is a free service. It is called Docker Hub. And so it's hub.docker.com. Let me see if I can log in there, and I'll show you some examples of what I mean by leveraging other people's work. So this is Docker Hub, like GitHub, like Docker Hub. And the idea here is that you have repositories where you put ready-made Docker images and give it to Docker Hub. Many companies, many organizations have actually provided a ton of contributed repositories. For example, we talk about this application called WordPress, right? So that is just one example. But there are people, 10 million pulls of this official WordPress repository available. This is our official WordPress repository on Docker Hub. That is exactly what I use, by the way. This is the one I use. Then there are other people making their own WordPress. Bitnami, Basebox, App Container, Century Cloud. This Century Cloud is your CenturyLink company. CenturyLink company and CJ Alliances and this and that. And everybody and their brother will have their own version of Docker WordPress. But the official Docker WordPress repository is available right there. And you can just pull it. You can basically, like Git pull, like Docker pull. You can pull it and start using it. That is exactly what I do in my example. In my dashboard, you will see that I seem to have where is that? Not this. I seem to have a CloudGenius WordPress repository, which has been pulled 250 times. So it's very low compared to like thousands of pulls for 10,000 pulls for official WordPress. This one only I'm using, probably maybe some other people, but not many. And then the data container that I mentioned here has a data image, the WordPress image, the proxy that I use, and couple other images here, the VPN image, and a do nothing much image. This is a interesting example to start with. It actually does nothing, but it gives you a flavor of how do you construct an image. And we will use some of those ideas. And the idea essentially here is that you have a ready-made reference model where you can build whatever application architecture you want quickly using building blocks, like Lego blocks. Just pick and choose what you want and assemble it together, and you have a ready-made thing going for you. And all of it is abstracted away from the underlying, so you can basically take that thing into any cloud you like. So you don't like Azure, for some example, like your customers complain that, hey, Azure is slow. They don't know whether it's Azure or not, but they tell you that the site sucks, your site is slow. So you know that, you need to go away to some other place to find out if there's a better solution. And you just take your containers and boom, bingo. That's the way we will we'll do it. But for right now, I want to finish out what we were doing. We have a couple of things to do. Like here, this exercise, I want you to be able to do it on your own, maybe after tomorrow, when I will repeat the primitive of this, like the one box example first, and then I will do this. I would like you to also do these exercises again. So for tomorrow, I will repeat module number 8, all of it. It's pretty exhaustive. And also do module number 9, which is the discussion that I just had, which is about separation of concerns. And today, as according to our schedule, we will actually talk about creating our own Chef server. And already, why do you need a Chef server? You need it because sometimes companies want to control things on their own. Sometimes companies want to keep stuff in their firewall. You have a company here, and they want to put everything inside the firewall. And that is a valid concern that people have. And so what companies do is they would like to have this Chef server also inside the firewall. So one approach is to have that company, chef.io company, have them, can you please bring your Chef server and put it here? That is a valid approach. They will do that. This is called hosted Chef. So this company will manage your Chef server in your company firewall within your boundary, and that is hosted locally. So I think it's called Private Chef. I think the name, they keep changing the name for it, but it's a service. They charge money for it, and they maintain, manage it, and that is a commercial product available. So that's one scenario. But then some other companies actually prefer that, we will do the whole thing ourselves because it is all open source. We can put every single thing inside our firewall, including our own Chef server. And we don't need anybody from outside. No. So if that is the case, if that is a need, then you need to use open source Chef server. And that is available, by the way. As you know already, you can go to GitHub and Chef server and look it up, and it's right there, here. You will also notice that this Chef server has at least a couple of different tags. So there is a tag called Uncle, Uncle Ned, Uncle. So these are randomly made names. Developers have some fun sometimes, maybe all the time. And then we look at down there, you will have a version called 12.8.0. That's the version, the latest version of Chef server released. Then we have some older versions of Chef 11 as well. So down there you have 11.3.1. That is a released version of a prior iteration of Chef server. And this is maintained as late as 2015 was the last commit, a year ago, roughly about a year ago. So that was Chef 11.3.1, the server version. Now, we have been using Chef 12 all along. We have actually updated to Chef 11.18 and then all that good stuff. However, both these versions of Chef, like the tag that you saw here, like 12 whatever, 12.8.0 and 11.3.1, both of these are valid use cases. There are some license changes in between 11 and 12 versions of Chef server, and those changes are here. The user interface was open source, and here the user interface is not open source. So it's a revised user interface, and they don't give you open source for that, which is what that company decides. But that's okay. You don't need the UI. This user interface may not be necessary because it's all mostly command line. You can actually operate on that Chef server directly without having to deal with your. You can basically clone this repository that we have here in our Chef repo and connect to Chef server. We don't need the UI because you can operate through Knife, cookbook list, Knife node list, Knife client list, a Knife cookbook upload, role upload. All these things can be managed purely through a Knife command, and you don't necessarily need a UI. Not needed. In fact, that is the dominant way people tend to use Chef, and the tooling is it's mostly on the command line. People typically not use user interface, but sometimes people want it. And that is where the version 12 of Chef actually has taken the UI closed source. So it is not open anymore. You cannot get it by default when you install this. Nothing is visible to you in a browser window. So you can get that as a license and get the UI if you like, but the version 12 does not come with an open source user interface. So that has to be understood. And with that, the company that you work for or work with can make that choice. Do you want to run version 11 of Chef or version 12 of Chef server? You can have Chef client. The client of Chef can be version 12 and interact with version 11 of Chef server. That also works. However, it is a business decision whether you have to make, essentially whether you want a user interface or not. If you want a user interface, you would go here and you get it for open source. But here, it is not available in open source. You have to actually buy it. So that trade-off you have to understand. And with that idea in mind, and there's a chat question there. Let's see what that question is. Could you demonstrate in the practice for quickly? Okay, quickly, I will do it tomorrow. How about that? Because the problem is we have a lot to cover. So I would like to do that, the separation of concerns in practice. And so the question was, can we demonstrate it? Yes, I will do it tomorrow at after the whole exercise for one box. We'll separate the concerns in two boxes. We'll do it all things tomorrow. I hope that's okay, Salam. And so with that idea, what I would like to do is help you with the Chef server exercise right now. For example, here is to build your own Chef server. So as you know, the thing that you would like to do is you can, installing Chef server is, you can do it manually, or you can do it the Chef way, which is, I would like to have, basically use a box that I will have my future Chef server. This is the future Chef server. It is currently just a box, but this is going to be my future Chef server. And I would like to have this box become a Chef server. That's the goal. So, to enable that goal, I would like to use Chef Solo and have this box convert into a Chef server. This is in the future. For right now, it is just an empty box. And so that is what I want to be able to convert. So the state from initial state that I have to a new state or a desired state is of a Chef server, and that transition of this state from that state, I would like to enable using the Chef way of doing things by using Chef Solo, apply that to this box, and then that box becomes our Chef server. And then everything else that we did the other day, all along with the Chef server, you can just use this box as your Chef server, and then you don't have to go to this site, which is the Chef server that which is a commercial product, by the way, and it has limitations, like you can only do 5 nodes. 5 is not enough by any stretch of imagination. You will have more. And so the scenario essentially is, this is a commercial product. If you want to have your own Chef server, you need to build it. Now, building a Chef server is actually pretty darn easy. It's really, really easy. And all you do is just take a cookbook for Chef server and define a node definition in Chef Solo and invoke Chef Solo on the target box, and boom, you get Chef server. That's it. That's it. It's as simple as the very first exercise we did. Like, if you remember the very first exercise with Chef Solo, it was, take something that you want to build into a Apache server, and then we converted that box into an Apache server, as simple as that. And we use Chef Solo, if you remember one of the earlier exercises, like module 5 and 6, like here. If you remember first solo run, Chef in solo mode, module 6, that's what we did. Very similar to that exercise is this exercise, is to have your own Chef server. And setting it up is as simple as the module number 6 that we have already done before, by the way. So setting up Chef server requires a specific type and size of box. So remember, you cannot use anything that you feel like. You have to use a particular box. That's the requirement. And so you need to have at least 4 GB RAM. That's a requirement. You cannot get a cheapo $5 box in DigitalOcean. Although people enjoy that $5 boxes, and I also do. However, for this exercise, you need to have a big box, which means you go to DigitalOcean and you log in and you get a bigger box. Let's see if I can log in properly. Where is my one password? There we go. DigitalOcean and my token. Copy it here, and I'm in. So in that you have to actually create a droplet, which is going to be a little bit bigger box, like $40. That is a requirement. You have to have a big box, otherwise it will fail. It requires more memory. Chef server needs that, and that is why we are choosing that box. Another thing to remember is the operating system version. We have to get 12.04 LTS version. That is also required. So remember that we are getting a 12.04, which is not the default. The default is 14.04. So you have to actually click down and select 12.04 64-bit. That one. 12.04 64-bit. That's a requirement. You have to choose that box and then have a $40 droplet, and everything else, whatever you feel like Singapore or San Francisco or whichever city you want to pick. And then add your key, like here, the key I have in my virtual machine. I will go to the virtual machine and cross-check my key. Just a quick second. Want to make sure that my keys are correct. So I can verify that by catting out the contents of my key and comparing it. The last few characters are 1K, 2K delta. And so here, the 1K, 2K delta also shows up at the very end. So that's the right key. So this is one of the reasons why sometimes DigitalOcean logins will ask you for a password, is that you're not selecting the key like this. That's the reason. Now I have selected that key there. I have also selected a 12.05 version of operating system and a $40 droplet and San Francisco region and my key ID RSA, and I just need one droplet, and I'll call it my Chef server. That's the machine I would like to create. I'm not going to hit the button right now, but just waiting for it. Now let us see that what do we need to do is to create a kitchen, basically, in which we will have this thing work. So we will create a kitchen, like create an empty folder, and then create a gem file in there, and then like that. So basically we'll create an empty folder and open that folder in our Atom editor. And that editor, in that editor, we'll create a gem file just like that. So I'm editing Atom, adjusting it on the other side so you can see it properly. And then I'll create a new file and save it as my gem file. So in my newly constructed folder, I will have this new file created, gem file, and save it. Now in that file, the body of the file, what I will do is paste a couple of gems that we need. And so here are the 3 gems we need to begin with. Is the knife solo gem, which is basically getting us to run Chef Solo on a target machine. We'll get Burkshelf and also get Chef gem. So these 3 gems, like that. And I'm going to save it. Now I have gem file ready, which means I need to close it, the window out, so I don't mess with it. And then, excuse me. And then I will basically bundle. When I bundle, I get those 3 gems and the corresponding dependencies. They will all be coming down, and that should finish very quickly. Not so quickly, apparently. So whenever you see native extensions, it takes time. That gem bundling finishes, and okay, so we have success. We have seen these gems now ready, so we should be able to make use of these gems to create what we want. So that's what we want to be able to do. So we have bundled, and now we should initialize a kitchen. So initialize a kitchen through this command, which is bundle exec knife solo init. So essentially we are creating a folder structure, which is what I'm going to do right now. And in that folder, I am basically running bundle exec knife solo init dot, meaning create a kitchen in that location. So it does. It creates a kitchen for us. This kitchen is now ready. It is very empty right now. As you know, all of these things are empty. Most of these folders are empty, as you can see them. But we want to create a node, and that node we need to actually make it ready to become our Chef server. That's what we intend to do. But before we actually put some things in the node, we want to get some cookbooks down. To get something to become something, we need to have that DNA created. So we are going to use a ready-made cookbook that actually helps us in setting up Chef server. And this cookbook is available in the supermarket. The prescription is right here. This is the prescription of all the books that we need. So we'll ask Burkshelf, can you please get these books for me? And Burkshelf will go and do that. For that, we need to make sure that we modify our Burks file. And that Burks file that we have there, we need to remove it and put this content in there. Now we will run Burkshelf and ask Burkshelf to get these books for us. The Burkshelf will go and grab those books and put that in the right location. So we will run Burks install next, like this. And by the way, in this location, you see that I have made a mistake, and that mistake, if any, we can point in the blue highlight. Can you point out what the mistake is? The mistake is that I am not suggesting that you please use bundle exec. So I'm just suggesting that you run Burks install, but it should be bundle exec Burks install. If you run it without bundle exec, it will gladly fail on you, and you don't want failures. So I just modified that writing, and now the instruction is, please use bundle exec before everything Ruby. Otherwise, it will not be disciplined about what gems you want to use, and it will just confuse itself and do whatever it feels like and fail. So you don't want that. When you're using a gem file, you should execute everything in a context of the bundle, and that is what this command is: bundle exec Burks install. That is what I will do right now. So in here, in the terminal, bundle exec Burks install. This command will grab all the books that we want from the supermarket. It will basically get us the Chef Server cookbook, which is what we now have. We have obtained the Chef Server cookbook and the corresponding dependencies that we need. And the next logical step is to actually create a node. And that node will basically become our Chef Server. So create a node in the cloud, which is you go to DigitalOcean, grab a droplet that is your Ubuntu 12.04. Choose $40 droplet. That is important. By the way, this is not going to cause you a huge amount of bill because this $40 is a monthly charge. They prorate on an hourly basis to about 6 cents per hour. So if you run it for 2 hours, it will be 12 cents. And you probably have a $10 credit card ready. So that should take care of it. So it's not really expensive, but just saying that remember to kill the box when you're done. Then you will not be hit with a bill. Don't get hit with bills. And it's okay to get a bill, but only when you actually make use of the machines. If you're not making use of the machines, you're letting the machines run up and running all the night, all day long. There is no point of doing that. Don't leave machines up and running without a reason. Kill them, terminate them, get rid of them, stop your bill. Don't want to unnecessarily waste money. Don't do that. Don't waste money. So having said this 12.04, $40 droplet, and this region you like, and then your key is important. This key, you select that, choose one droplet. We need one machine, give it a name, something like Chef Server, and then you create. So click create. That creates a box. The box will be a big enough box for us to actually install Chef Server and succeed. And that DigitalOcean is actually right now creating that box. As you can see here, Chef Server box, 4 GB droplet is getting ready in San Francisco for us, and we should have an IP address in a minute. Once we have that IP address, we will note that and put it right in this location. That becomes the, the Chef Server for us. So we need to have that IP address in this place and in this place. That has to be modified. Now I'll grab all of this and put that in a node file. This node description, we need to create a new file in the nodes IP address.json like this, nodes IP address.json, for which I need the IP address. So I am getting it. I'm going to copy the IP address like that, copy. And now I have the IP address. I should be able to go and create a file called nodes/IP address.json. But it's very similar here. And I will create that file in the Atom editor and save it in the nodes folder. Remember, nodes folder. And here, IP address.json. That's the file name that I have created now. It shows up in the nodes folder underneath here. And some of you tend to walk away from this folder in the terminal. You will probably go to the nodes folder like this and look at that file, and the file looks all nice and beautiful, but it is empty right now. So we'll fill it up like this. Sorry, not this content, but that's the content I want to actually put. However, you just have modified your directory location to a different folder. I don't want you to go to another random location like that. I want you to stay in this location. So you cd ... back and be there in that location, which is where your kitchen location is. So you stay in your kitchen when you run a command, you will not have any issue. If you go out of the kitchen to some other folder, it will start failing and you will wonder why. So having said that, we will now create this node description, which is, this is how it begins. So you take all of this, copy it, and let us understand what it says. So I'm going to paste it in that node IP address.json file like this. And now try to understand what it does. The first thing I notice is that the IP address is wrong. I need to use this IP address. So I will copy that IP address and not use this wrong IP address, which I have here. This comes from a previous exercise. So I'm going to replace it and put it this new correct IP address for the fully qualified domain name FQDN for my Chef Server is that IP address. And I can use a DNS name by putting a DNS entry and creating an A record for that, and then use the DNS name, and then that is also okay. But for right now, I'm just using the IP address itself. So that is my IP address for the Chef server, which I will develop. The API FQDN also remains the same. I will install the Chef version 11.1.6-1. That's the version I want. So don't deviate from it. This exercise is just for that version. And then you are enabling the web user interface, so you can actually see the UI and making it true. And then in the run list, we are saying update the app cache and run the Chef server cookbook default recipe. That's the description of the node that we have. We will save it, close the window back here, and we are getting ready to create our node. So next step, we'll just go to that machine. Bundle exec, knife solo, bootstrap, root at IP address, all that. That's what we need to construct in terms of replace the IP address, provide our key, and solo bootstrap. You remember what it does. This bootstrap command will not only install Chef, but also run the kitchen, run the Chef command with our kitchen. So it will upload the kitchen from Chef Solo locally and run that kitchen on the target box. That's what that command will do. And so I'm going to just paste that command in an empty window here and take my IP address from this location and replace this IP address with the correct IP address for that box. And now I should be able to grab this entire command. My key is all correct. IP address is correct. Address is all okay. Knife solo bootstrap is what I want to run under the context of bundle exec. So don't forget the bundle exec part. So taking this whole thing from the notepad and giving it to the terminal here on the other side. I'm just making it a little bit bigger and invoke. So I will invoke Chef Solo to operate on that target machine that I have in the cloud. This machine, and this machine will first install Chef in there, then run Chef Solo with the kitchen that we have now created here, and then using Chef to install Chef server is what is going on. As you can see right now, it is first installing the version of Chef we wanted. This is going to install the Chef client correctly. This is the Chef Solo client. You are now uploading the kitchen. And then the kitchen is available and understood. In there, the actions, the first action is apt cache. So that's the first action. And the second action is to get Chef server version 11.1.6.1. And that is the version of Chef server that is actually getting installed on that remote machine. As you observe it, this box basically is getting converted into a Chef server for our use. And that IP address becomes the IP address for our Chef server, which is what I will use in place of this Chef server that we rented. We rented from the company. They gave it to us for free for 5 nodes. And that's that box, which is not what we are going to use anymore going forward. We will use this. And this is the box that we have in our company. We own it. And we are converting this box into a Chef server like this. In one command, becomes a Chef server. But then, let's see how it actually worked. So does it finish? Not yet. It is still doing its thing. And when it's done doing its thing, it will tell us that it did. And then we have to somehow grab those things that we are very used to, right? We are very used to using that starter kit, which gives us a ready-made thing for us to just download whatever we feel like and like download the starter kit and all that. You remember they give you a nice kit to begin with all the knife RB configuration, your PEM files all loaded up and ready to go. Now this part, you have to do it yourself. Because it is open source, you can. And we will do that exactly. We have to construct piece by piece, element by element, generate a PEM file, and grab it from our own Chef server, bring it locally, and use it right here with us. That is our own server, so nobody's going to help us spoon feed us in terms of, hey, here is your PEM file, go use it. Or here is a starter kit with a starter cookbook and all the knife configuration nicely adjusted for you. Nobody's going to give it to us like that. So we have to build it ourselves. That's the challenge, but it's not hard. It's not that difficult. So let's see if it finished. It did. This, by the way, will not finish. It will not succeed if you do not select a 4 GB droplet. The machine has to have 4 GB RAM, without which it is not going to succeed. This thing will fail for RAM. However, we have enabled a web user interface. As you can see, Chef Server Web UI enabled true, and that is, we know that already, which means our IP address here, we can actually see some web UI. So let us copy that IP address and go to a browser. Let us see what it says. So here we go. What do we see? First thing we see is your connection is not private. Absolutely not private. You know why? Does anybody know why? Why is this complaining? It says your connection is not private because there are issues with the site certificate chain.
Yeah, this is Salam.
Hi.
Hi, because it's open to the world, you know, it's all 000.
No, that's not the reason. The certificate is invalid. It is not trusted. The reason is it is giving you connection not private is because the certificate that we have put in the Chef server that we just created using this step sequence is a self-signed certificate.
Oh, okay.
Signed. I signed it myself. So my browser doesn't know that I signed it myself. So it is complaining. I don't know this certificate. I did not sign it. Who signed it? You? Yes, I did. So I signed it. It is a self-signed certificate. That's what the complaint is. It actually read that very, very clearly. It says view the certificate. It says the certificate is self-signed root certificate. And if it is signed by you, then your operating system doesn't have any idea who signed it. So this guy, by the way, this is a new OS, came out yesterday. It's the Mac OS Sierra. It is going to come out actually in fall. This is a beta version, and this is looking nice. You know, the beta is looking very nice. I'm running it beta in a real machine. Like I'm using it regularly for the last a day or so. It came out yesterday or the day before, and I've installed it. But this OS, the Mac OS Sierra, does not know that this certificate is actually properly signed. There is no way for Apple to know that I'm going to sign a Chef server certificate. That is why this guy complains. Similarly, this browser, which is a Google browser, it doesn't know, Google doesn't know that I have signed. So it doesn't trust anything that is not officially signed by Google or by Apple or by Microsoft or by any operating system vendor. And that is the root of the problem. So we have to tell that, yeah, I know, I have signed it myself. And you can just, okay, advanced and proceed. And it says it is unsafe, but you know it is not because you signed it. It tells you this server, basically if you read that language, it is very clear. Your connection is not private. Your attackers might be stealing your information from this IP address, for example, passwords, messages, credit cards, etc., etc. Hide the advanced. So the advanced section will tell you more detail about what's going on. This server could not prove that it is indeed that machine. Its security certificate is not trusted by your computer's operating system. This may be caused by a misconfiguration or by an attacker intercepting your connection. But we know it is us that have actually set up the server, which has in turn using a self-signed certificate that we created through Chef Solo Run. So we know that it is okay. So we have to go back, go forward and say proceed. Yes, I want to go there. So we are now saying yes, go ahead, override, please go, take it. I signed it. So take it. So here's how the Chef server user interface looks slightly different. But on the other side, on the left, on the right side, they have given us admin password. And this is open to the world. Anybody can actually see this password and the admin login and can log in right now. And so I need to quickly log in and provide the password they have given me, and then log in. And I did. It says, please change the default password, which I should quickly change, which I will. And here it is telling you to regenerate private key. You don't have to do that, but you can. There is an option here. And we save the user. It basically changes the password. It is giving you the corresponding public key. You can grab the public key for that user, and it is available for you to download. You can copy that public key if you like. But this is the web user interface, which is nice, but that's not what we actually use. We use our terminal to connect to the Chef server itself and get those keys directly onto our workstation. And that's what we will do next, so we can actually start using this Chef server instead. And so let's quickly look through the clients portion. The clients, we have two clients here, the web UI client and the validator client. We have data bags with nothing, cookbooks with nothing, nodes with nothing, roles with nothing. So basically the similar user interface that you see here in the, this is the version 12 user interface, by the way. But this is the older version of Chef that used to exist until last year. It is still there, and it is in use by many companies. However, most companies that I know do not actually use the web user interface. What they do is kill it, actually. They kill the web UI. You have seen the web UI, by the way, here. And you should also see a couple of other things on the same method, which is basically shows you a list of all the libraries that got installed with that particular Chef server that you have installed, which is this IP address. Sorry, that IP address is here. So if you go to that IP address again and go to that location called out by /version. So we'll go to that IP address followed by /version. We should be able to see all the libraries that got installed in there. And here is a long form description with MD5 hashes, Git hashes for all the libraries that got installed alongside your Chef server with specific versions that get installed when you install the Chef server. These are the components that got installed. You can see all the detail if you want to. But again, as I said, not many people actually that I know that actually use this web UI. So the next thing I want to be able to do is to disable the web UI. So the Chef server web UI enable will make it false so that this UI goes away. So we don't have to leave this UI open-ended. So we will go here in our JSON file. If you remember this, there is this Chef server web UI enable true. I will make it false and save and close. And then run my bundle exec knife solo cook. I don't need to bootstrap again and again because it's bootstrap means install and run. I'm just going to only run. Don't need to install again. So cook. And when I'm cooking it, it is going to modify the web UI property, making it false. And that's the change it will do. And so you will see that that change is happening. It will disable the web user interface. And it just did that. At the bottom, you can see it made it false. It was before it was true. Now it is false. The before was minus here. This minus sign shows that it was removed. True was removed. False was put in place and restarted. So now this web UI that we have that shows you this interface and also this interface is all disabled correctly. It shows you bad gateway because that gateway has been disabled. So we have actively disabled the web user interface for our own Chef server because we don't want to actually use it. Having done this part, let's connect to the Chef server ourselves. So we will go to that machine directly and get the things that we want to access from there. Hey, if you if you have a cannot see a terminal too small, is that still too small, or should you want me to make edits? I can make changes if you want to make I can make it different like this if you like. Does it better? Is this better?
Yes, Nilesh.
Okay, so you should say this in voice so I can actually get attention, because otherwise that chat, I was not looking.
Oh yeah, I know. And somebody's ringing the bell. Did he hear?
I don't know. I don't hear it.
Okay, I heard like some bells is off and on.
Hold on. Let me get this. I think it must be the window causing the problem, I guess. Hold on. Okay, that bell must be this. Stop the bell, I guess. So the bell should not actually cause any more noise. Must be that bell outside, I guess, that you may be hearing. So what we just did is that we disabled our web user interface, and now we should make it a little bit more bigger and connect to that machine directly, like this machine IP address that we have. We'll go to that machine directly in our terminal. SSH root at, and just connect to the machine. So this is the Chef server that we have. This runs your, if you remember, Ubuntu 12.05, right? That's the box we are dealing with. And that is also the Chef server. In that box, there are a couple of files that we want to actually go and grab. Those files that I need are sitting in this location, etc Chef server. If you go and list that out in that Chef server, that is where our credentials are sitting. So I will go to that box here and list them out. That's where you will find that the admin.pem, the PEM file, the Chef server RB, and JSON files, and another Chef validator PEM, the web UI PEM. These files, the 3 PEM files, is what we are really after. But these files are sitting far, far away from us in the Chef server, in that folder, etc Chef server. So we want to bring them down to our local machine here in our workstation. And we can get them. First of all, we just saw them, but now we can come out of that session that we have with the Chef server. So we exit. We saw that these files exist there. So we came back to our workstation, and now we want to construct a command that will remotely connect to that machine and bring down all those files, the 6 files that we saw here. These 6 files, 1, 2, 3, 4, we like to bring them down. So there are these commands available, ready, written for us in our example. And that is what we will do, is to grab these 6 lines of code that will help us bring those 6 files to our computer. So these are the 6 lines. And you remember that the IP address we need to modify. So we will go to the IP address and modify. And now we have the command constructed. By the way, you just saw me do a multi-line edit. That is a capability of Atom Editor. You can totally do that. It is actually pretty fancy. You can go like this and say paste. And that is just powerful. I mean, you can do this across a large file and identify all the same pattern and repeat and quickly replace. This is a capability of Sublime, Atom, and a couple of other modern editors. They will let you do multi-line edits and even multi-line cursor. You can see that my cursor actually is a multi-line operation. You can see that. So I'm operating multi-line. That's a decent thing to have when you're dealing with code. And that is what is just powerful. to make use of these things. Now, having said that, we have modified our command that we want to run. If you look at the command itself, it is basically making a secure copy connection, SCP, connecting to the remote machine, going to that folder at C chef server, and then grabbing that file and putting that in our .chef folder right here in the .chef location, like that location. That's where we want to put that. We don't have those files. They are there in our remote location, by the way, right? In that location, you see them. You see these files, but I don't want to. I don't want to be there. I want to come back to our workstation and run these commands. And these commands will get me those 6 files, one at a time. So let's go grab them. 1, 2, 3, 4, 5, 6. So we have those 6 files in our .chef folder. Beautiful. That's what we wanted to get, and we now have them. That's the thing that we wanted to download in form of a ready-made, what is known as starter kit or a chef repo. We can grab that ourselves like this. Now we have the files that we need, but we need to now configure our knife RB file. And this knife RB configuration, there is an automation available for that. So it will actually create that thing for us, which is what this command does. So you want to basically create, and by the way, as you type these things, I would like to caution you that this will fail the very first time you run it. When you try to configure knife with the knife configure -I command, when you want to run this command, it will fail. It fails SSL validation for an obvious reason. And the reason is the certificate that you have signed is a self-signed certificate, and nobody trusts that certificate. So you can either skip this first attempt and jump to this idea and actually mark that certificate as trusted in the terminal. Like in the browser, we did this, okay, I understand, let me go thing. We can do that thing also in the terminal, and that is what we will do. But first, I would like to actually fail and read the failure to understand what's going on. And so this command, as I run, will actually let me see the failure. So here is the command I want to run. I will take that command in my terminal and run it. It says, there's a knife RB file already in that location. Do you want to override it? Yeah, I see the file, and it is something that I got by default when I initialized my kitchen, but not that one. I don't want that. I want to use a newly constructed knife RB file, which I want to configure myself. And I want to use it with my chef server, which is this IP address, right? So I will say that, you know what, get rid of the knife RB that I used to have before. I don't care. I'll say yes, kill it. Okay, then give me the URL for the chef server, please. And so the URL for my chef server happens to be https:// remember the S part. It is a secure URL you need to have. And like this. This 443 is the port number that you want to use. It is not necessary, but if you want to change it to a different port, you can, and then you use that different port number. But that is just an example way of saying that you use secure protocol, and that is the link to my chef server. So I'll copy that here and provide it to this configuration command like this. And say, okay, here is my chef server. So it says, enter the name of a new user. In my case, I can say my username is user, or I can say Nilesh, or something else. So you can make a name for a user for the chef server. Like in another example, I use this name, or in this example, I will use this name. It doesn't matter. So just make up a username and give it. And enter the name of an existing admin. You know that the name of the administrator is admin. So you just type that. And the location of the existing administrator's private key. that location that we have, this location actually is the chef server location. But if you remember, we have copied it locally, so we have it here. And you know where we kept it? We kept it in our .chef location, and that is the admin PEM. So we have given it in the .chef location, this admin PEM, we have copied it locally, right? So we will just say .chef / admin.pem. That's the reference to what we have in our current machine configuration. So that is the location. .chef / admin.pem is the PEM file for that admin's private key on the chef server. We have a local copy, so we just use it. The validator client name is the same name that you want to keep. We are not changing it, so we'll just enter. And the location of that validator is actually, again, .chef. So we'll take that name and / validator, no, sorry, full name is chef validator.pem. And now path to the chef repository, you can leave it blank. And then you have to create a user's password. The username is Cloud Genius. You're going to create a password for this user. So I'm going to create a password. And it says, we attempted to connect, the SSL validation failure happened. Because we don't trust your certificate, we could not establish a secure connection. We established a connection, but the connection was not secure because your certificate is self-signed. So you could knife SSL check to troubleshoot your configuration, but if your chef server uses a self-signed certificate, you should just mark that certificate as trusted by running knife SSL fetch. You're basically fetching the certificate and keeping it locally. So we will like to run the knife SSL fetch command because we know that it is a self-signed situation where our chef server is self-signed. So we want to run this knife SSL fetch command with a prefix of bundle exec. You remember the bundle exec has to be there every single time you're running a Ruby command. So this is what we want to run. And so we'll fetch that certificate, and it actually drags down a copy of the certificate and places it in here in the trusted certificate list. And that is the certificate that we have on our chef server, which is self-signed, that was downloaded and is kept right there. And we will now basically run that same exercise again to configure KnifeRB. Do you want to delete KnifeRB? I'll say yes, please. Do you want to give me the chef server URL? I'll say yes, I have it here. And then I'll give it. Do you want to create a new username? I'll say yeah, I'll use the name Cloud Genius. Existing administrator, just use the name. The location is .chef / admin.pem. The validator client name I'll use as is. The location is .chef / chef validator.pem. And then API password for this Cloud Genius user. That's what I will create. And now it should create a new knife configuration KnifeRB file for me. And it was written to this .chef folder, KnifeRB. That is the correct configuration for our example with our chef server that now looks like this. And you will see here, this configuration is constructed for my Cloud Genius user with the chef validator for the PEM file that is now available to me. This is a newly generated PEM that is also saved in the .chef folder you can see here. .chef, this PEM file came down. It got generated and it's saved locally. The chef validator PEM, this file came from a SSH SCP, the secure copy. And this is the knife configuration that our chef server is recommending us to use. And it points to our chef server. That's the chef server URL. It is not manage.chef.io. It is our own chef server. That's how you configure. Once you have it configured and you have a knife RB created, you should you should modify it, modify a little bit, so that it does not hard code reference to that folder. Right? This is a hard code reference to that particular folder. And what happens if you go use this knife RB to another folder? You will have a problem. So the way to overcome that is to actually remove those hard-coded references like we currently have in our example. And these hard-coded references actually come from the fact that this exercise was done in that folder. So you want to remove those references like this. There are multiple references, 1, 2, and 3 places. In 3 places you find them. You want to actually remove these references and put a generic Ruby reference like here, like current directory reference. So whichever directory it is sitting in, you want to make it in a reference to the current directory. Basically replace these things with this. Replace this thing with this. This thing with this. And so having done that part, it makes our knife RB portable. You can take this knife RB to another location, another folder, and it will still work because it is in reference to a current directory variable, right? And so we have to actually compare, make it edit, make the chef knife RB file, edit in lines with the example that I have provided here, which makes it complete. So let us grab all that and let us understand what these things actually are going to do for us. So our older, or rather newly generated knife RB looks like lines number 1 through 8. And what I'm suggesting in the website write-up is like this. So let us compare. Current directory, we have to define it. That definition is missing. We have used it, but then we have to actually define it. The definition basically says current directory is the place where I am currently. And that is the first line I define it, which specifies what does current directory mean. It means wherever this file is, that's the current directory, right? Next up, we have to, actually the current directory does not have these elements, so we have to modify those also. You will see that the log level is info, that is okay. So we'll get rid of this line, log location, std out, that is okay. You get rid of this line. Node name is correct, we get rid of that line. Then the client key is slightly incorrect. We have to get rid of these words. So we are deleting them. And that client key now matches. Syntax, this is correct. I think the syntax check cache path is, no, this is not correct. To delete these words like that. And now it is correct. Yes, the validator client name is correct. Validation key location is incorrect. We have to modify this also. And now you can delete this line. The chef server URL, that one is correct. Not this, we get rid of that line. The cookbook path, we want to keep this path, which is our reference to site cookbooks and cookbooks folder. The node path and role path and data bag and environment and all that. We need to keep all of these things. We'll just keep all of them together like this. And now we have an updated knife RB file that actually works in our example, no matter what folder we use it with. So now let us go test it. Does it actually connect to our chef server? And bundle exec knife cookbook list. It says, there's a reference could not be loaded in, private key could not be loaded. I think your private key, this is an error in our knife RB. I think I made a copy paste mistake somewhere. Let's go verify that in knife RB. Our client key. Let's compare this. What is my current location? Okay, your private key could not be loaded from home user chef. It's a dot chef followed by current directory. Okay. Let me carefully read this. So I think this may be a reason where use of double quotes versus single quotes. That I think is the root of the problem. And I want to validate that. In our example, we seem to be using single quotes here. Whereas the example that I have, and I remember having done this and having run into this error before also, is that it needs a double quote string in Ruby. And that is what I think is generating. So what I'm going to do is find all these single quotes all over the map and replace them with double quotes. So like find all of them and then just replace all of them with double quotes. And make sure that there are no mistakes in there. There is a mistake apparently. So I'm going to clean it up. The mistake is only in one location. So I'm going to fix that part here and now save it. This should address the concern that Ruby had about the nomenclature. The string has to be inside. So the problem is this is getting not evaluated properly. And so let us go check one more time, and it worked. The problem indeed was that Ruby expressions need to be in double quotes, not single. And that's a Ruby requirement. Now, having understood that part, we know that our chef server that we have live in DigitalOcean correctly works with bundle, exec, knife, node, list, all these commands that we operate with the chef server, they will all work because it is properly connecting to the chef server that we have and getting us what we need. So practically, we have our own chef server working. Now, do we need a web user interface for it? Absolutely not, because we can operate just like that. Why do we need to spend money on a commercially available product if we don't have to? That's a possible case. In some use cases, actually recommend that. Most people who are developers actually are okay if they don't have a web UI because they don't need it. And that's the dominant usage where we have. So we have modified our knife RB, made it portable. Remember, this double quote usage is critically important when you're using Ruby expressions like this. That has to be clearly understood, that it has to be double quote. If it is not double quote, it will fail, like it did for me. And the example generated uses single quote, which in that example, it works because we are not using Ruby expressions yet, like this hashtag, and then reference to current directory. That reference is not there in the example, and that's why we have to remember to change it. Now, after having changed this, we can now communicate with the chef server. We did knife user list, chef, knife client list, all these things. We just saw it working. It is properly connecting to our own chef server, and now you can bootstrap pretty much whatever you want, whatever infrastructure you want to create using Chef as a foundation. Send your kitchen, cookbooks, roles, nodes, data bags, everything to the Chef server that you own and manage, that you have currently in this cloud. So we have this cloud running, and that box is our own Chef server that we are using, and we can continue to use it. It will cost us $40 per month, but if I stop it right now, it will cost me 6 cents, as you know. So remember to destroy your machines after you're done. Now, having done this part, let us understand the idea of how do we actually make use of it. So we can actually create something like this. So bundle exec knife bootstrap and create a new node like this. So having confirmed that you can connect to the new node you created. So we are basically creating a node and then configuring it using our own Chef server. We can do that part. Now this is actually trivial. You have basically replaced the underlying Chef server that you were using before. In the other examples that we have been up until now, we are using the chef.io provided Chef server. Now we are doing, what we're doing is our own Chef server. That's the only difference, as you see. These guys have a newer version, we have a slightly older version, but that's the case. That you have to understand that. That's the current difference. However, we are not limited to that. We can also go to version 12, and that exercise is also provided to us. I think in this step, should be the next step, if I remember. So in this example, in this particular step, I think I'm just building and playing with a new node that you will create using your own custom Chef server, like this one. Like using this Chef server, our own Chef server, we will operate on some cloud and create some thing that we want using Chef. That's this step that I was looking at in here. However, that is trivially simple too. I want to actually skip it. You can do it yourself or skip doing it. It's not really necessary as such. Chef server has been set up correctly, as you saw. Having understood that part, let us see the next idea, which is setting up Chef version 12. This is the version 12 of Chef server that has this capability to have a user interface installed on top. But it does not, it is not an open source component. This user interface part is not open source, and I would like you to realize that very clearly. Having said, we can do this exercise. It's a slightly different way of accomplishing the same thing. But at this moment, I would actually take a short break and ask you this question about do you want to do more of these the variation of Chef server, or do you have something else in mind that I would like to actually cover? That is what I'm really listening for in terms of, we have more examples to go through in terms of setting up version 12 of Chef server and using that instead of version 11 that we have just set up. So we can practically delete this box, like destroy, and the box goes away. As simple as that. And here it goes. So it's gone. We just killed our Chef server. And we can now build a Chef version 12 server if you like. But my question that I would like to ask you is, do you have something that you want to us to discuss before? Or is this something that you want to actually do, is follow along and understand what is the difference between 11 and 12? Because that difference that we see in between version 11 and 12 is more of a licensing and a commercial difference as opposed to deploying it is very similar. So the question I'm really asking you guys essentially is, do you have any questions at this stage? That's the question. Before we, we'll take a short break right now before we switch topics. So the questions are welcome before we actually take a break. Any questions? Anybody? You guys are so quiet and muted. No questions? Okay. No questions is fine. So right now it is 6:47. We'll take a short break and resume. Hey guys, I'm assuming you're back also from the break. So just
Yes.
quickly checking. Yeah. Okay. Good. Just quickly checking audio. That's what that was.
We're here.
Okay. Good. So, did Chef bore you enough? That's a real question I wanted to ask. Are you bored of Chef? That's the question. Because I have inflicted quite a bit of Chef on you, and so the question is, really, are you tired yet or not yet? Do you want more of Chef or you want me to change the topic? That's the real question I'm going to ask. We'll do Chef again tomorrow. I'm not going away. I'm just asking you this question. Do you want some variety or you just want more of this like I just showed you?
No, let's change it up because I'm a little lost with Chef and I want to go back and try to figure it out. But this way I don't get lost any further. Let's change it up a little bit.
Okay. So I can actually talk about a different topic, a little bit different topic.
A little bit is good.
Yeah. So because Chef can cause what I call mental indigestion. There's so much of stuff that just flows at you like, nonstop. And it can cause indigestion because it is too much, honestly. There are too many moving parts that just, you don't understand this and that and the whole thing. And we will do it again. Don't get me wrong. We'll do the whole thing again. We'll do the most complex exercise again tomorrow, which is at 5 o'clock tomorrow, which is this module number 8. And that, many of you actually have completed, which is nice. But just doing it all over. That encompasses comprehensive understanding of what Chef can do for us. And we'll do this tomorrow. But I guess in my mind, this very last step that we have right now, module number 11, we can run it, and it's not that difficult as such. But I think what I have in mind, as I heard you also say, is let us discuss something little different. And I am thinking that I will describe to you this concept of Docker, which we will do more of as we go along. But the concept that I want to actually build and have you also build is called a Docker file structure. Like, you know this in various examples we have had: gem file, chef file, Burks file, and now comes Docker file. Now, what does Docker file do? It basically describes your intention. What do you want to put in an image? An image is basically what you put in a container. I'll just throw a few words at you and without explaining to you. So I should actually explain these words that I'm going to use. So I use these words container quite a bit. I have used it. I have also used the word image. But what do these things do and what do they mean and how does it actually relate to this Docker file that I'm describing? What's the connection? So an image is pretty similar to, if you think about, you go here, say, for example, MSDN downloads. So go to your MSDN downloads from Microsoft and they will give you an ISO image, right? You've seen this ISO image for Windows and you can download them and make use of them and install it on a box. So here you can get Windows 10 and here is the download available and there it comes. So it's a large ISO file, right? You can download the ISO for Windows 10 if you have a subscription to it. Similarly, you can go to ubuntu.com and ubuntu.com and download the ISO image for your desktop Ubuntu version or server Ubuntu version, whichever version you want. You can just download that Ubuntu version and the download will come down to you basically in form of an ISO file, right? Here it comes. I don't want to actually download, but I'm describing that thing that you download is an ISO image. It is an image of an operating system. Similar to that concept is this concept of a Docker image. It's not really an ISO file, but it is an image, and it is an image constructed out of a Docker file. So you will have, hold on, let me just close these windows out and close that window out also. And I'm changing topic a little bit because I am actually giving you a Docker example for you to actually get your feet wet. You will be able to do this yourself along with me as we discuss. So what I want to be able to do is describe to you what is that image. You will create an image using a Docker file. That's what we will do right now. You will write a Docker file and create an image. Now you have an image, so you can send the image over to Docker Hub. And that's where images are stored. These are basically files, a collection of files that constitute an image. Now, when you take an image and run it, so you have the hub, that's where you put your images. You can also download your images if you like. So up and down both ways possible. You will construct these images using Docker file, which is just a simple text file, by the way. And it is very, very simple to actually use and create and all that. Compared to what we have done in Chef, these files are trivially easy. So you will see them in just a minute. So you create an image that you want using a Docker file, and then give that for the hub to save. So it is kept safe there. And once you have it saved there, you can then use the hub to bring it down if you like. And you will use that image when you bring it down to instantiate a container. Instantiate as in run a container, basically. So when you run that image, that you bring it down, and when you run it, it creates a container. That's the operative structure of using Docker, like just to beginning to use it. So you have to understand these constructs that I described. The ideas are image, which is a file. You construct that image using another file called Docker file. And once the image is ready, you send it to Docker Hub. When you want to use the image, you bring it down from the Docker Hub and use it. When you use it, you basically run it. And when you run it, it becomes a container. That's the idea. So these are the words. So I'll use these words, container and image and Docker Hub, quite frequently. And I don't want you to cause any confusion between container and image. Container is a runtime representation of an image. Got it?
Okay, hub is acting like a Chef server here.
There is no Chef server at all.
No, I'm just like comparing, like, you know, Chef server is giving us knife.rb and some other files, so we can use it.
Right. So the idea of Docker is slightly different. Actually, it's very, very different. So don't mix it.
Okay.
Okay. So what I would like to describe is Chef is a tool to configure, operate, manage, deploy, whatever you want. Whereas Docker is like a virtual machine, if you will.
But
Yeah.
Docker
is like a virtual machine.
Yeah.
Not really VM. No, it is not. But
It's a lightweight
more
machine.
like a machine. So Docker is like a machine. You will create like VM in a cloud. That's what you get. And then you run your OS there, right?
Mhm.
Docker, when you have, it just runs an image. And think of it as a machine. But it is not a machine. It's not a VM. But it works like a VM. Works completely like a VM, almost. As long as the operating system is Unix, Linux. As long as this is Linux and Unix, then all of this works just fine. It works like a machine. So Docker basically gives you a container which is like a machine, but not really VM. So it is different. We'll talk about those concepts. But the best way to talk about these things is to actually create an image ourselves. So we will do one. So we'll create our own image very, very quickly. And you just watch me do it. This thing is not written down. So it is not complex either. But I'm just opening up a new folder. We'll call it Docker test. Go in there. And there we have nothing. So we will open up Atom editor. And in that editor, we'll create a new file, empty file. We'll call it the Docker file. So new file, save. Inside the Docker test folder, we'll call it Docker file. That the D has to be capital. And save. That's the Docker file. That's it, empty right now. Let us now understand what is a Docker file. So let us get to some examples available to us maybe here. And we'll go to Docker to see some examples right now. Let us see, we can go there. Docker file, how about that? So we'll just see some Docker reference. And here are some examples of a simple Docker file. For example, let me identify a very simple one to begin with. Let's see, where is that? These are unnecessarily complex. You know what? I'll build one myself. Just go to an example, pull up an example that I already have, and just use that. So I have an example here, which is a good one to try, which is called do nothing much. It does nothing. And so let me identify where that source code is. So I'll grab the source and then bring it to you. The source code is here. No, not this. Why is it taking so long for me to find it? Docker WordPress GitHub. Yeah, this one will be a good start for me to pick an example Docker file. That's it. So I will make it really, really simple. So here is an example file. That's how it begins. Okay, let's understand. So in our Docker file, we will put something like this. Let's remove the name Eugene. We'll call it Nilesh. That's it. That's a Docker file. You know how many lines we have? 2. This is a complete Docker file, by the way. A complete Docker file which does nothing. All it does is it stands on the shoulders of giants such as Ubuntu 14.04. That's the image I want to use. So that's operating system image already available. So I'm just declaring that use that image to begin with. The foundation is Ubuntu 14.04. And I'm going to maintain it. That's my Docker file. Let's see. Save it. Now I can build a Docker image out of this Docker file just like that. So if you look at my Docker file, it is these 2 lines. If I want to build an image out of it, I'll say Docker build image. So it will build that image. It will pull down all the things needed for Ubuntu 14.04 and then do nothing because it does nothing. Or the lines are only 2. That's it, these 2 lines, like from line and a maintainer line. So just, I will maintain it, but what I'm basically doing is making a reference to the from line, basically grabbing the Ubuntu image provided to us. And that is the image now downloaded from Docker Hub for 14.04. And in the next step, number 2, declare the maintainer is going to be me. And now we have a new image. It is called 9 Foxtrot 5 6, whatever that number is. That's the image now we have. Let us see how many images we have. Let us make it a little smaller. And how many images we have? So we have an Ubuntu image and a Debian image and a CentOS image and all that. But bottom line is, we also have this image with a name called nothing, no tag, no name, but an image ID that I created 34 seconds ago, and it has the size same as Ubuntu 14.04 because that's what we just did. So we created a new image out of this image, the Ubuntu image. But that was just do nothing exercise. I mean, this is just creating an image, relying on some other image, and just building on top. Now let us. I want to do something interesting in that. I want to actually have that image a little bit customized. So when I start that image as is, if I just instantiate that image, this 99F56 image, that number. So I'm just taking that number right now, and I'll say I want to run that image. So when I run an image, what will I do? Is I'll say Docker run, and then that image. And in that image, I want to run bash. That's the command. So now I'm running that image. This image is Ubuntu 14.04. Based on the image that I created, I now have a container. My container ID is this, which is not this. This is the image ID. This is a container ID. So you saw me creating a container by running the image. When I run an image, I get a container. That's the concept I described before, right? Here you had the idea of an image, and I did not even bother to go to Docker Hub quite yet, but I just used the Docker file to create an image and then instantiate it, basically run it to get a container. That's what I did. I just did that. So I wrote a Docker file, 2 lines. Then I built an image file. Then I built an image using that Docker file, and then I run it directly. When I run it, I get a container. That's what I did, right? You saw me do that. So we have an image and a container. We did not bother yet to go to the hub, but we can. It's not an issue. It just the need to have a login name on that site, which is what does it. So as soon as you have a Docker login on that site, you can create an image and push the image or pull the image and do things like that. But we are not doing anything material, anything useful. So I want to actually do something, at least a tiny little bit useful stuff. What that can be, let us identify. So I want to maybe say that create in that container that runs my image, which basically builds up on top of the Ubuntu image 14.04 that I have. And I want to make it a little bit mine, like totally me. So I can create that image by creating a file here called touch and nilesh.txt. So that's a file available now, right there. It is called nilesh.txt. And now this image is a little bit different from the Ubuntu image. This is my image, right? But I haven't actually created an image yet. I have created a container and then modified the container runtime by creating a file inside. By touching nilesh.txt, it gets created. And that is what you have. This is in the running container. The image still does not change. This did not change. This container ID changed, right? I did not yet change the image. I changed my container runtime, and I now have the file. I can even modify that file and say that, this is my file, and then save it. And so now I have that file that I modified, and it says, this is my file. So that's the file. It is in my folder. It is in the container. But remember, I still did not modify my image. My image did not get modified at all. Now, if I come out of this container, the container will die. It died. Let us see dead containers. This is how you find dead containers. And you have a dead container called Goofy Lamar that had the number 9F6EA, which is the same number as this. 9F, that container died 6 seconds ago because I killed it. I exited. As soon as you exit a Docker container, it dies. So you have to keep it running for it to live. It can die itself if it crashes, but if you leave or exit the container is supposed to die. So it died. That is good. We have a dead body right there. This was based on this image, and this is the container ID different from the image ID. Now, if I run another instance of the image that we have, this image, which is the same as 9F5, that image, if I run another container, you notice that I do not get this ID again. I get a different container ID because it's a different container. See, my container ID is FB29, not 9F6EA, but FB29. It's a different container. Do I have that Nilesh there? No. I do not have Nilesh.txt because it was in the dead body. It doesn't exist in this image. This container does not have that Nilesh.txt. This dead body here had it. This image does not. And this image is what we used to construct a new Docker runtime container that does not have the Nilesh thing here, right? We don't have it. We can create one, but that's not the point. You can create something else like cloudgenius.txt, and that file now exists in this container. The cloudgenius.txt now is there, but it is in that container, this one, which I will exit, and now it is a dead container. You see that this container FB29 died about a minute ago, 4 seconds ago, and this container died about 5 minutes ago, or 2 minutes ago, and they were both based on the same image. So I can keep creating new containers like this, and you will find that it does not have those modifications that I keep, they go away. I create a file, and the file goes away because the new container gets created based on an image that is still the same. I want to change the image, actually. So how do I do that? Now I have, by the way, 3 dead containers, the 3 dead bodies, Docker ps-a, 3 dead bodies sitting there. Okay. But the image is what I want to actually change. So that image, we have this 95F, that number, this number is what I want to actually change. Docker images. This image ID is what I want to modify. And you know how it was created? Do you remember? We have a Docker file to create that. So I have to modify the Docker file to actually create a new image, without which I cannot modify the image. The only way to modify the image is through a Docker file. So I will open the Docker file here, and here I will modify something in the image itself. How do I do that? I'll say copy something to that location. And this something needs to exist. So I will create that something and save it as something. And now I want to copy that something file onto the image at the root location. let us check the copy syntax. Is it accurate or not? So I'm going to check the copy syntax. Hold on. Which I will do here. Docker file copy. And here's the reference for it. So you can just quickly check the Docker command reference. The copy command is pretty much like this. Copy file, test file to that location. By the way, Docker for Windows is coming. And I just got invitation to try a preview earlier today from Microsoft. So that means Docker and where is that? This guy invited me. Yeah, here. So this is ACS preview, Windows preview nomination. So it's a Docker file for Windows and all that is coming. You see some of those references with Windows core running from Windows Server core, copy test file to that location. So you see that these examples are Windows references, but they will apply to Windows, not Linux. And we are basically taking similar examples. In our case, copy this something.txt file to the root location. That's what I'm doing. I'm going to save this Docker file, close out the window, come back here, and understand that my change Docker file looks like this. And now I am going to look at my images that I have already. So I have this image. Now I'm going to build a new image. This image that I built was built 11 minutes ago, right? So I'm going to build another image, Docker build. And this time, it will actually do the third thing. The third thing is actually copy. This copy thing, it will do. So it did very quickly this time because the other images were locally available. It did not need to download this Ubuntu from somewhere, Docker Hub. It used the existing reference to this image already. So using that image, and then did this copy something to root location, and now has created a new image, this one, which should show up in our Docker image listing. Do we have a new image? Yes, we do. And it was created 29 seconds ago. Now, if I use this image to run a container, what do you see? Docker run. You see that you have that something there. Where is the something? There. The something I copied over to the root location as opposed to the slash location. So it went there. And it is going to be there all the time. Even if I remove it from here, and now I don't have it, and I exit, which means I have another dead body. And so that dead body that I have is based on this image 2EE. And that images that I'm using is this 2EE image, the same one I used before. You remember I removed that item called something from that image, so from the container, which is this container. The image still has it. The image does not get destroyed or modified at all, even if I kill something in a runtime environment. So here, run another container, go to /root, and you will find that something is still there. So you get the concept there, right? You understand these concepts clearly now, I hope. And if you don't, ask questions. The concept that we just did was that we created like a simple Docker file with three things, like go to Ubuntu, Ubuntu 14.04, and then call me maintainer, and then copy something to the root location. That's how you should build the image. So we build an image.
Mm-hmm.
And then we instantiate a new container, run a new container, and we saw that something there in the root location. And we want to delete it, but this deleting it from this container does not delete it from here. It's still there. It is still there as it was. Right?
Nilesh, how about the size, if I need a small size or big size, how I can manipulate that?
Size of what?
Size of the container, the emails.
Okay. The size of the container will expand to fill the available space of the underlying hardware.
Okay.
Okay. So you basically, unless you actually limit how big or you want to make it really constrained, you can limit how much resource can it use. But if you do not specify anything, it will just grow to what the machine can handle, the physical machine.
Okay, within the physical machine size.
Yes, yes. It will grow and basically assume all the resources are available to it, and that's how it will behave, as if the whole machine is on its own resource. So it will just occupy the whole space available, occupy all the CPU needed, unless you limit it. So you can limit using control groups in Unix. There is this idea called C groups in Linux. That's what you should be using, and we'll go through those examples later. However, that is for sizing a container. You can limit, put constraints around how big can it grow, how much CPU can it use, how much memory can it consume, how much network capacity can it actually use, how much disk space can it take. Things of those things you can put constraints around using C groups. But I'm just illustrating core concepts right now. We are building image. We did that very quickly. We build an image. Build image. How did we build an image? We used Dockerfile. Then we run the image. When we run the image, it becomes a container. In the container, you can do whatever you like, delete, create, whatever, but it does not impact the image. The image still stays the same. To modify the image, you need to actually use Dockerfile and then build it again. So Dockerfile build to get an image, run the image to get a container. Right? So Dockerfile build will get you an image. Image you run to get a container. And container is basically a it's a runtime of the image itself. You can do whatever you feel like in the container and destroy it, but it does not destroy the image. To modify the image, you need to modify Dockerfile. That's how it goes. Simple, plain and simple, right? So now, we'll take a slightly more complex example and understand how can we modify our Dockerfile that we have right now here. How can we make it a little bit more complex, right? So I will edit our Dockerfile here. And instead of Ubuntu 14.04, I'm going to use something else and modify this also. And let me just check the syntax of the name of the image I want to use. So somebody has created a nice image here. I will just use it right now. So let's go there. On Docker Hub, we should be able to find that image. It is called Tutum WordPress. So Tutum is a company that got acquired by Docker. And that is the image I want to use. So let us get that one in. So that's the syntax. Okay. So I have this syntax now, and it is a different Docker file, by the way, as you can see. And I'm going to just build it. So what will I do? What will I do is now that new Docker file I have, I will build it. Build. So the Docker build. This Docker file in the folder, and it builds. So it will basically pull down all the needed components from Tutum WordPress and put my entry of something.txt in the root location. And then I will have a new image that basically is built on top of the image that I am using, which is actually getting downloaded right now. It is about 200 MB large, so it is taking a little bit longer because it is a comprehensive image, which is what it is getting pulled down. Once the pull completes, it will build my own slightly different image that looks like this. It has this copy something.txt in there. And you will find that file inside the WordPress container, which is what I'm building right now here. When it built. So it has a newer image of Tutum WordPress downloaded. Then I add a maintainer line, and then I add this file copy something to some location. And now I have this new 76E, 076E image available to me. I can make use of this. How do I do it? Let's see the dead processes we have here, all these dead bodies. And here we have all these images. We also see that we have this 76E, 076E image, so 34 seconds ago created. It's about 476.5. And it is based on the Tutum WordPress image, which is also about the same size. That image was updated about 3 months ago. This image I created about 34 seconds ago. I want to use this image to construct a new container. And you can see that Docker run will get me that image. Now in that image, you will find that something is there. You will also find that the proper way to run this image is not how I'm running, but as defined in here. It will run it like this. And that is what we need to do, which is to actually open up certain ports from the container and map it to the real machine, right? This is a port mapping that we have to do that we did not do in the first instantiation. So I'm going to exit that. And what I am describing to you is that this run doesn't actually open the ports that we want for WordPress to become visible. As you remember, this is a WordPress container created by Tutum. And so I want to actually map, and this port mapping is a little bit involved concept, so I want to explain that to you. In our machine that we have, the Cloud Genius workstation, we have a port number 80. In our Docker container, which is what we are running, which is going to be running, which is based on this image, 76EA. So this 76EA image that we have, I will be creating a new container based on this image. And I want to make sure that the port number 80 on this container, as you recall our discussion, Docker is more like a machine. It is actually a completely functional compute unit. So this port number 80 on the container needs to be mapped to the port on the underlying machine. So here on this machine, you can open Firefox and you should see WordPress running inside the container. But this port mapping has to be done correctly. And that is what we want to actually do. So in this example, I did not do that. I just ran it quickly to see my something.txt, and I can do it again, and I can see it again, but that's not the point. You see the something.txt, but that's not how this particular container is designed to run. It is actually designed to run like this. Docker run like a daemon, like perpetually keep it running, don't exit. Not like I run, like the way I was running is Docker IT is to run it interactively in teletypewriter mode, get me a TTY and execute the bash command, bash prompt, so I can actually interact with it. But that is not how you actually work with a WordPress instantiation. You actually want to keep it running all the time. And that is what we need to run this command slightly differently, not invoke bash, but instead run it like a daemon, and map the ports 80 to the port number 80 outside, and then run that image. And that is what we need to do for that to operate like a proper WordPress. Now this is a direct reference to the Tutum WordPress, whereas this is a reference to the image I created based on the Docker file that I have here, which also uses Tutum WordPress, but it has this added element. This is my element added on. So when I run it like this, like a daemon, not interactively, like a daemon, what I'm going to basically do here in this example is to leave it running all the time. So if I run this command, you will see that the command just quickly resumes back to and almost apparently does nothing except gives me a long GUID. This long number is a reference to a running container. So you saw dead bodies before, right? Docker dead bodies of all the machines that I killed. However, you see that this E3035, whatever that number is, E35, all that long number, shortened up to only so many digits, is what you see here, is actually up. It did not die. It is running for the last 14 seconds. It did not die. That is something you should remember, that you started the container with a -D option. So the container does not die. It stays running all the time. That is what you see here. Now, if you run the same query again, Docker PS, you will see that it gives you only one line, which is the running containers. So here, run again, Docker PS, you see only one line here. You don't see Docker dead bodies. I'm using the word dead bodies for a reason, because they are actually dead containers. There are lots of them. All these other lines here down below, they're all dead bodies. They're exited. They have fancy names like agitated Vishweshwaraya, distracted Veskoth, sharp pear, dreamy swirls, tiny boar, adoring and goofy Lamar. And our currently running container is thirsty Archimedes. So these fancy names, Docker gives it by itself. You will also see that the only running live container is thirsty Archimedes right now. It is running for about 1 minute. It is based on this 076E image, which is what I created using our Docker file here, this one. And other containers that you see in the Docker PS-A option also shows you all the dead bodies. Whereas if you just type Docker PS, you see only the live container, which is only one right now, and that is this container. The container ID is E35. The image ID is 076, which is built on this image, this Docker file. And it has been up 2 minutes. It has its name, Thirsty Archimedes. But the most important thing to note is the port mapping. This port mapping shows you that port number 80 on the physical box is mapped over to port number 80 on the container. So it actually opens up port number 80 on the container right here and associates it to the machine port 0000:80. And that mapping allows us to open localhost on the machine here in the browser, Firefox. And we should be able to see localhost in this location right now and see what it shows us. You will see that it shows you WordPress. It does because it is that's what it is doing. It is running WordPress on the container right now. So you saw WordPress, and it is running. Where is it running? In the container. Which one? This container. Which image? This image. How did you build it? This is the basis. 3 lines. In fact, actually, you don't even need these 2 lines. That is just, just to illustrate a point that we have something .txt that we can modify something a little bit different. It's not really useful, but just driving the point that you can. And we will actually make modifications to the images that are available out there from the community, like Tutum has provided this WordPress image. So we will use those. And I actually use this, and many people use these images, but this is an all-in-one image. It also has MySQL running, as you can see. Port number 3306 is open, which basically is the port for MySQL. So the idea is that that port is open for internal use by the container. It is not connectable from this machine outside. This machine you look at, this machine cannot go to that port because the port is not mapped out like this one is. This is not mapped. This is mapped. That is the port mapping. And you saw this in a runtime representation when I started the container. It was this mapping explicitly called for. Hey, please map port number 80 in the container to the machine outside. And that mapping is requested right here. And that is what you see in the image here, which we are using. It is running right now. So I don't want to start another instance of the same container, but just examine that the docker ps command will show you that that container has been up and running for 5 minutes. Now, if I want to connect to that container on a terminal, how do I actually go in? So there is a different command for that. It's called docker exec. And let me connect to my container. I have to give a container number here, E35, and then run bash please. So I should be able to now connect to that container. I am connected to that container right now. Here, E35, container ID, running container. And it is showing me the port mapping. Now, if in here, if I go ls, I will find that something.txt because I placed it there, right? This Docker file does it. It places it right there. That is what you find there, this line. It is just a demonstration of placing something inside an image through the Docker file syntax that you saw. You also saw that this is running your WordPress just like you want. And that is the image that I used. I built it myself using another image, which is called Tutum WordPress. Now let us see how Tutum actually builds that image themselves. By the way, before we go to Tutum, let us understand here that this container is running for 5 minutes. I'm going to exit this docker exec command, which is I'm basically connecting to a running container, docker exec, execute bash interactively in this container. So docker execute bash, which is the shell, docker execute bash interactively in this E35, that container. So run bash in E35 and give me a handle. That's what you have here. And you can see the content that you placed. I'm going to exit. By exiting, Docker does not die. That container will not die. It is still running because it is a daemon that you started. So you want to kill this machine, you can totally do that. But that will then stop WordPress. So here, this WordPress will go away as soon as that container dies. So you can kill those containers and along with them, all the dead bodies, all these dead bodies we have, and one live container. You can kill all of them. There is some command for that I'm trying to remember. So it will list out all the containers, all the dead bodies, and kill all of them. So now we have docker ps-a showing nothing. And so if you open up Firefox, you should see localhost unable to connect because our containers are dead. We also have these images, right? We can kill these images also, like this one, I don't care. or maybe I do. If I really care about it, this was like 14 minutes ago. If I care about it, I can send this image to somewhere safe. I want to keep it safe, I can do that. Or rather, I would actually name these guys. So here's a repository name and a tag name. I don't have a name for it. So let us build it again. This time attach a name and a tag and all that. So let us do that. Here's what I'm going to do is I'm going to Docker build again, put a name, -t tag, tag it with a name, let's say CloudGenius / Tutum WordPress. And that is the name I want to give, and build it again. And now you see that it builds. All it does is just attaches a tag to it. Now you can see Docker images will show you CloudGenius Tutum WP, latest tag with the same ID number 076E. That did not change. All we did is attached a tag like this to the dot location. Don't miss the dot part. Docker build dot. And this tag is just a reference that we wanted to have so that these names properly occupy. Once the names are taken, you can then send this particular image over to Docker Hub. How do you send an image to Docker Hub? Like here, do you have a Docker Hub image called Tutum in the CloudGenius Tutum WP? We don't have it here in the CloudGenius repository. There is no Tutum there. So if I want to send an image out to Docker Hub, what I need to do is push. And how do I push? I need to have a login name first. So I'll grab the login name and password for Docker Hub, which is what I'm doing, is grabbing my password for Docker Hub, and then copy the password. So I have it. Once I have the password in my hand, I will now Docker login name and password, and then Docker push. So I have the Docker images there. I want to Docker images there. I want to Docker push CloudGenius / Tutum WP. Push it. It says refers to a repository. Oh, I have a typing mistake. I cannot type CloudGenius properly apparently. There we go. So it should push Docker Hub, my image from this location to you, and you should be able to grab it. Now, when that image goes up in the Docker Hub cloud, you should be able to run the same thing like I am doing by running this command, something like here. So I will type the command now. The command you should be able to run on your machine just like that will be docker run -d -p and then the next command to this, by the way, will open up and run Docker for you. And you can open Firefox and go to localhost. There you will find it running WordPress, and you can also connect to the Docker running instance, Docker exec -it, and then you put the container ID here, and then ask it to give you a bash prompt. You can get the container ID from Docker ps-a, or Docker ps should give you the container ID. So I think I'm going to paste these steps on your chat, and you should be able to play with it right now. It should work. So on your machine, let me just quickly check if that push finished. Yeah, it did. So push finished, which means you should be able to run these commands just like that. It will work. Try it. You should find that you're going to use my image that I'm going to give you. I just gave you, and that image you should be able to download, use, run WordPress inside a container on your VM, connect to it, and also check out that something.txt file also exists in there. You should be able to see the same thing. Like I'm going to do the same thing here. I just did, by the way, but I'll do it again. Docker ps-a, no containers, great. I will now run Docker, what did I type there? Okay, run like a daemon, map the ports, and then run the Cloud Genius / what was the name I chose? Tutum WP, and run it, please. So it runs it. I can check Docker PS and find out that the container ID is 65 alpha alpha. So that's the container ID. I want to connect to it, Docker exec, and then interactively go to that container. Oops. Oh, close, not doing it right now. And then the container ID is what I wanted to copy. So kill it again, clear, Docker PS, get the container ID, copy the container ID, and then Docker exec -it, container ID, and give me a bash prompt. And here you will see the something.txt right there. You can come out of it. It does not kill the container. The container still is running, and it is running just like it was before. And what you need to be able to do is Docker ps to see the container, and Firefox localhost to open Firefox and play with Firefox and that live installation of WordPress that you have. And that's the way you can use the image that I create, give it to you. You're running it locally on your workstation as long as you have Docker, which you do on your workstation. So you can basically transport images to other people on your team, give them what you have, and not only that, customize it just like you want. How do you customize? Like this, something.txt. I just made a custom modification to a publicly available image from Tutum and gave it to you. And you should be able to run it. Tell me you succeeded in running it, because that Tutum should show up in my Docker Cloud right now, right there. Where is Tutum? Try the steps. Here it is, Tutum WordPress. And so, yeah, somebody actually pulled. Looks like some of you pulled it. Yeah. So you should be able to pull it and run it on your workstation, just like I am. And you should also see this file there, something.txt. So please tell me that it worked for you. That's what I want to hear. Anybody? Or not yet? Maybe it is pulling, right? It takes time to pull about 500 MB a file. It takes time to pull, but if it pulls successfully, it should run. It should run, and not only that, show you WordPress, and also give you that something.txt file. When you enter in the machine, enter the container, and list out the files like I did here before. And I'll do it again. Docker exec it 65 AA bash and ls. You should see that something, and the 65 AA comes from here. Container ID 65 alpha alpha, and something.txt is what you saw. And I'm going to exit. And this time I'm going to do a cleanup. The Docker cleanup is docker -rm-f $docker ps-aq and kill. So it kills all the containers I have, all the dead bodies I have. Docker ps-a shows nothing, nice and clean. So that's what I did. What did you do? Did you succeed? Anybody?
Not yet.
Not yet. Okay, I'll pay. I'll give you a minute or two. It takes time to download the thing, so I understand.
Neelaj, do you have any cheat sheet for Docker?
I do. There's somewhere. I just have to find it. There's a cheat sheet somewhere here. I just have to locate it where it is. Let me see where it is. Not in this DevOps section probably, but it is there somewhere. Let me find it. Is it in technology? I tend to forget where I keep things, and then I go looking for it, which is crazy. This happens when I just randomly pick a topic out of the blue and then talk about it. But I guess, like you said, it tends to get boring after some time, and just putting chef down the head doesn't work all that good. I've seen it many times. So you need time for chef to digest. It is very hard to digest, unfortunately. And so, but Docker is relatively easy. You saw this example. Oh, yeah, Tick says it's working. That's awesome. That's great, Tick. So let's understand now what did Tutum do to build that thing. They built a lot of things in there, right? They got acquired as a company, and what did Tutum do? What is Tutum doing? Let us understand that. So in here, how did Tutum build this image for themselves? And they have it available to them, available to everybody in this location. Which location? Let me show you that location. So Tutum's repository is available publicly in Docker Hub, and you can just find it on here, search window, Tutum WordPress. And it has 10 million pulls. Is that right? No, not 10 million, 10,000 pulls. The third repository from Tutum WordPress. It has 10,000 pulls. And let us see the detail of this repository, which is the Tutum Docker WordPress. And let us understand what did Tutum do to build this. What was the Docker file that they used to build this WordPress? And you will find that this Docker file is not that complex. It's relatively very simple. Let us understand it. Let us go to the source code for this image, which is where we will find the Docker file. And that location happens to be this. So in Tutum Cloud WordPress repository on GitHub, you will find this Docker file, this one, which is how Tutum built that WordPress image. And then we used it, by the way, just on top, and added our something.txt, this line. That was just silly. This is silly. This is of no use. Just copying something randomly. It has no point, but it drives home a point that you can modify. Now, having understood that part, let us see what they did. So Docker file. Their Docker file is 25 lines long. Not that big, and it's not difficult to read. So let us read it. 25 lines, line by line. There we go. So first step, this is the Tutum WordPress Docker file. It is built on top of something else. What is it built on top of? It is built on top of Tutum's another image called Tutum Lamp. You see that line number 1? It is built on top of another image called Tutum Lamp Stack. It is the Linux, Apache, PHP, MySQL stack that Tutum has built in another file. So there has to be another source code somewhere for Tutum Lamp, which has a different Docker file that builds Lamp Stack. And this file adds WordPress on top. So it's a layered architecture we are dealing with. So underlying thing that we are going to look at is going to be LAMP, and that part is different. That's a different Docker file. This Docker file uses that Docker file, the Tutum LAMP latest, line number 1. We can find it, and we will go there just a minute after we finish these 26 lines, understand them. We will then go to the source of Tutum LAMP and read that also. We'll go iteratively all the way down until it says from nothing, from scratch, build this. That's how we should begin, right? Build from scratch, build from nothing. You will see some files somewhere after maybe 5 or 6 files down the road. We go deep, digging deeper. You will eventually find from scratch, out of thin air, build something and build on top and build on top and build on top like that to build a Tutum Lamp stack. That's what this line number 1 is. And then this file takes that Tutum Lamp and build WordPress. Now let us read line number 2. Very simple. Those two guys, Fernando and Feng, wrote this file apparently. They maintain it. Line number 4, actually 5. It installs some plugins. What are we installing? It needs PHP 5 GD for image handling. GD, PHP 5 GD is, I think, graphical something, GD. So that install is needed. That happens. So apt-get update, and then apt-get install PHP 5 GD, and then remove some random repository references that are not needed anymore. So that one line, number 5, 6, and 7 together are updating the apt cache, installing PHP 5 GD, and removing some unnecessary apt references that are not needed anymore. So just keep the image small. Get rid of crap we don't need. Next, line number 9. Download WordPress. So that's how it comes. So you just download WordPress by git clone. So it says remove the app folder if it exists completely, and then clone WordPress from GitHub. That's to get the source code of WordPress directly from GitHub, which is also available on GitHub. You can just get it from GitHub and put that source code in the app folder. Now we have it in the app folder. That's where our WordPress will sit. We add some wp-config.php file in the app folder. And this configuration is what we do by hand when we type something like give me a username or give me this and give me that. That wp-config basically connects the application with the database. That's what it does. So you have the LAMP stack already built in underneath. And that app WP PHP configuration is a file separately stored in the same folder here. In this folder, you will find it. That's the file, wp-config.php. You want to move that file over inside the app folder in the image that you are building. So that wp-config is the configuration you want to place in the app folder inside the image. That's the addition of that file into the image so that this application can connect to the database, which happens to be running on the same container. And remember, my choice of word has changed a little bit. I'm not saying box anymore. I'm saying container, because it is the same container that will run LAMP, all of it, one shot, one container runs it all. So it is the local database inside the container. That's where this WP config allows it to connect. So this is the connection configuration. Next one, we are modifying some permissions for plugins to load correctly. And so the ownership goes to www.data and www-data as the group ownership. Both ownerships to that content and to the var www HTML folder structures, and underneath recursively we are modifying permissions. That's what we also did in the chef example, if you remember. And then set up database. So we are creating administrator user script and placing that script inside in the image. We are creating a database.sh script and putting that script inside the image. We are modifying executable permissions on those two files that we place inside the image. This one as well as this one. Both these files get executable permissions. Then we open up port number 80 and port number 3306. These are two ports exposed in the container. And then we run something. What is that something? That's a separate file that is also available in the same folder. It is called run.sh. So where is run.sh defined? It gets created, I think, from here. One of these steps will actually create a run.sh. Let's identify where that run is. So YAML Docker file. So this run.sh has to be a file somewhere available in the LAMP stack probably. So it has to exist in the image somewhere. And that is the reference to line number 25, which is what gets run when you invoke this particular image and run it like a daemon, like we did before, like most of us have actually. You can get the ID working, WP is working, you can get the container ID by running docker ps-a. If you docker ps-a, it will give you the container ID. So yeah, I think Tosin ran into an error. The error is bind address already in use. So either you are running some Nginx or Apache already on your workstation, which is occupying your port number 80. That's what this error is about. So I should describe both these things.
Yeah, now I think I know. I have to kill those processes.
Yeah, you have to kill Apache, you have to kill Nginx and uninstall them probably. So you have these two guys, one of these two guys running and occupying port number 80 on the physical machine,
Right.
the virtual machine you have. And so this container mapping to port number 80 is failing because you have these guys running there, occupying the port. So you kill them and then run it again, it will work.
Okay.
Right? And docker ps-a should give you container ID to go in and examine and all that. So that should happen. Now, this reference is basically a reference to some file inside the image that you will find at somewhere down the chain as we go and explore deeper. So, Tutum latest. Where does this come from? Let's go find out. Go do a Google search. Tutum latest, where are you? And so here it is, GitHub, Tutum Cloud, LAMP stack. And that is a separate repository to build the LAMP stack image. This is Tutum Docker LAMP. Tutum is I think it's a Turkish word. I don't know exact meaning of it. But what's the meaning of Tutum? Tutum means, what's the meaning of Latin phrase? Is it Latin or Turkish? I think it is Turkish. Because the founders are Turkish. So Tutum means attitude. Okay. Tutum means attitude in Turkish. So that was tutum.co that got acquired by Docker. And that's what Tutum Docker LAMP is a LAMP stack that gives us out of the box LAMP image, PHP, MySQL, all included one shot. So let us see the Docker file for these guys. So what does this Docker file show? Let's read. Click. The Docker file is 43 lines long. And let us understand it. It is built on top of Ubuntu Trusty. So that's the foundation. Then Fernando and Feng are created this file. They are running Debian front-end non-interactive, which is basically don't interact with me as I run Docker build because there is nobody to type anything. Docker build command will run by itself. So don't expect any interaction. That's what line number 5 sets. Then it updates apt cache, installs a bunch of things like supervisor, Git, Apache, libapache, mod PHP 5, MySQL Server, PHP 5 MySQL, PWGen, PHP APC, PHP 5 Encrypt, and then it sets the server name localhost inside Apache configuration, then adds some image configurations and scripts such as a start Apache script, a start MySQL script, and a run.sh. You remember run.sh in the other example, which is the higher level example than this. This was the LAMP stack, but above this we have WordPress, Tutum WordPress. So that is what is actually running the run.sh. That file, you will see it in this example. chmod 755 amifkidal executable. Then add this my.cnf MySQL configuration inside the image and set supervisor daemon to allow these configurations for Apache and MySQL. Then remove unnecessary pre-installed databases you might have. Add MySQL utilities for creating admin user and permissions for that same executable. Enable HT access for Apache by making sure that you set them and make a default conf file for Apache enable the module rewrite. So A to N mod is basically enable the rewrite module for Apache. Apache 2 enable module rewrite. That's what this thing does. Then we are cloning this app with a sample. So there is a sample Hello World application. They want to just put something in the app to show the utility of LAMP stack. And that's what this line does, is basically gets you the example that Fernando created. And that example is Hello World LAMP, and it puts that in the app. This just to make the LAMP stack itself meaningful for somebody who's using just the LAMP stack. That's why you see that the WordPress Docker file actually deletes this app directory when it starts to use it. It also sets PHP max file upload size to 10 megabytes, PHP post max size to 10 megabytes. It adds some volumes for database, MySQL, and then exposes port number 18, port number 3306, and runs the run.sh. Now let us understand what this run.sh is. So we'll go to the top level and find out what that run.sh is. And here is run.sh. And what it does, it basically executes Apache in Supervisor D. So that's what you're looking at. You're identifying your volume home location. You're modifying using serial editor, stream editor, upload max file size to whatever you defined in the other example, which is 10 megabytes. And post max size, you're modifying it, basically editing this PHP ini file with those variables that you have chosen to modify. Then it will get more complex as we go lower level. But as you see, if the volume doesn't exist for MySQL, then install MySQL, install MySQL DB, and then quit. Then if that's not the case, if you already find that there is a MySQL volume installed, then just use it, don't install it again. So if you don't have it, then you install. If you have it, then you just use it, and then execute Supervisor D to start the process. That's what you see in this step. That's what this run.sh does for the LAMP stack. If you keep going down deeper in the Docker file and look at the source of this, Ubuntu Trusty, how did they make it? We can find out what that Docker file for Ubuntu Trusty is. This image is constructed by Canonical Company. Their source code is on another location. We have to go find out what that source code is. But this is the original official Ubuntu image for Canonical, made by Canonical, updated 8 hours ago. And the Docker file for 1404 is this one. So let's go see. What does it do? So it is built from scratch, out of nothing. It has the foundation of nothing, and it builds, add a image. So this is the basic foundation image of Ubuntu Trusty Core Cloud IMG. This is the boot image for Trusty. Then you start some run policies. As you can see them, this can get a little complex for those who do not understand OS level boot. But that's what this is doing, is setting up Docker specific tweaks to make this container and this particular cloud image run correctly for Docker. And that's what you see in the tweaks here. All these tweaks that are being done basically are to make Docker happy. And then you remove other references to apt lists because they are big and they get stale. So you want to kill them all. So you remove them. And this forces apt-get update in independent images. That's what you need to do when you start a new image. You basically want to get apt-get update. You enable the universe for apt-get. That said is a stream editor, editing a file in line, in place, etc apt sources list will modify and enable the universe repository for you to be able to grab whatever you want from apt-get update, and then run bin bash. That's what the Ubuntu OS built on top of nothing, which is what was used by Tutum LAMP to build the LAMP stack, which is what was used by Tutum WordPress to build the WordPress stack, which is what was used by Nilesh to build the stack I gave you, which is the the stack I gave you was named Cloud Genius Tutum WP. So that's the stack that I built based on this WordPress image. I created this image, which is Cloud Genius Tutum WP. It builds on top of that, but essentially the whole work is happening in multiple steps. At the very basic foundation, you have nothing called Scratch. And on top of Scratch, you have an Ubuntu created by Ubuntu/Trusty. This is created by the Canonical company. On top of this, you saw Tutum create their LAMP image, on top of which you saw Tutum create the WordPress image, on top of which you saw me create the Tutum WordPress image, and like that. So my change here was a little tiny change just to illustrate a point. But the thing starts here, Scratch, and then you add the thing needed to make Ubuntu work. That gets you Ubuntu image. That's what called Ubuntu Trusty, and that's what you have in your workstation, by the way. So you might have a Docker image called Ubuntu Trusty 1404. Oh, they call it 1404, not Trusty. Okay. Sorry about the nomenclature. The nomenclature is not Trusty, but it's 1404. That's the name they use. And then everything else, you can keep building your layers up on top all the way. Now, the next time what I will do is we're meeting tomorrow, so we'll do Chef again. But in the subsequent steps, we will actually understand how to build a multi-tier architecture of the same WordPress deployment, but the Docker way of doing things. It's a whole lot simpler, And we'll do some exercises for that, and it is all written down nicely. But for the work we did today, there is no written steps. I just showed it to you live as I speak to you. And so you have the video recording, which I think you should watch when you get time, which I know you have a lot of, because you have nothing else to do in life, apparently. Sorry, that was a bad joke. But yes, it is too much to digest, and I understand. And we will meet again tomorrow at 5 o'clock. And I will also find references to the Docker reference somewhere here. It is written down somewhere. I'll find a location and paste a link for you who want to practice it. And with that, any questions?
So is this the last class for DevOps officially?
No, we have one more.
On Monday, right?
Yeah, we have one more.
I tried to look on website. I think it's showing the next sessions which
I updated it. I've been doing I've completed revised it. So yeah, I can give you the dates, but yeah, I have revised the whole thing, and I put the September dates up there.
Right. Yeah, that's what I was saying.
Yeah. So I'll send you paste a link with dates or something like that. But don't worry about it. I think this is the 7th session. We have one more session on DevOps, and I know you should talk to me, Anand.
Okay, sure.
After the session, so we should do that. And you should join tomorrow. I know you missed. You were in the hospital, so you should join tomorrow, and that will help you bring up to speed on what we just did on this. Chef deep dive. We will do it again once more tomorrow, redo the whole thing. We'll focus on module 8 and 9. So the intense ones. These are the ones that are really intense and deep. That has bogged down many of you. I'm sorry about that, but that's how Chef is. So there's nothing to be sorry about it, really. That's how it is. Cool. Any other questions? No questions? Okay, then see you tomorrow, 5 o'clock.
Thanks, Nilesh.
It's
Bye.
an optional session. You don't have to attend, but I know 3 of you, 4 of you have said that you will, which is nice. So you don't have to attend, not requirement, but you should. It's going to bore you enough and drown you in chef one more time. And so let's do that. Sorry
I'm
for
looking forward to it. So I will see you tomorrow.
the evil laughter. Yeah. Thank you, sir. Thank you. You're more than welcome. And I will, by the way, make sure to record it and give you a copy. Your copy is always going to be there. No worries about that. And but join you can, and be ready to practice, because tomorrow I want to actually do it with you, step by step. So we'll probably keep it collaborative, keep the mics open, and have you also do it along, because that will help. But doing is better than watching somebody do. And that is what I intend to do tomorrow. Thank you, sir.
Thank you, Nilesh. Have a good
Thanks,
night.
Nilesh. Bye.
Bye, guys.
Bye.
Bye.
Yep.
Hey, Nilesh,
Yes.
I have a question.
Yes.
You can stop recording. You don't have to
Okay, hold
record.
on. Let me stop recording. Hold on.
Okay.